Hey, welcome. Good afternoon. It's Friday. Everybody ready for the weekend? Having a good time? Stay inside just a little bit longer. We're hearing the news, little glimpses of hope here and there, but the good news is we're here. We're on to our latest topic around Axient Digital. We've been spending so much time with RF since we started. The RF topic, guys, is just been hot. From day two, I will say James Stoffel still wins for most registrations, most attendees. It's RF is just a crucial part of what we do in our world. And that's not just folks with microphones, but that's folks with cameras. That's folks obviously with intercom. Just the wireless world is around us. It's going to continue growing. And one of the challenges I think we face going forward is how do we not just manage the RF we have around us, but have the technology to protect those key microphones, those key paths that are going to be essential to the show. And so, as we've gone through the process since starting Practical Show Tech, we've come at RF a lot of different directions. Like we're best known for, we are unconventional as a group. And so we've talked about antennas, we've talked about antenna distribution, we've talked about how we use the microphones, but honestly, we've spent very little time on the actual microphone itself. And we thought, okay, well, let's start digging in a little deeper on that. And we know our audience is quite familiar with how a wireless mic works, right? And they're obviously very familiar with the Shure products. So this wasn't about saying, okay, well, let's take everybody through power up your wireless receiver and how to program your transmitter. This is really more about helping people. We'll do a little level setting. Joining us today is Michael Johns and Dr. Mark Kenkel from Shure, who are intimately involved, not just with this product, but so many of the products leading up to Axient Digital. And they're going to walk us through some of the intricacies of frequency diversity and quadversity and the real strength of those features. We'll do a little review. I don't know if you know this, but a lot of us haven't been in front of a wireless mic for a week or two. So, we'll just do a quick review so everybody remembers where the front panel is, where the back panel is, and things of that nature. But before we launch into that, see our audience is still safely coming in. Mac, Pete, hello. It's good to see you again.
Good to see you.
I think you went to work this morning, huh, Mac?
I did for an hour. Yeah.
There you go. All right. I do not want to hear you complain about your commute because, boy, it's probably as nice as it's ever been, huh?
It's as nice as it's ever been. Can't complain.
That's awesome. So today I would anticipate a few questions, and maybe in addition to questions, a lot of comments, because I'm looking through we have a lot of our attendees that we've come to know and love and have never met in person. But this is a product we all make our living on, and it's essential to what we do in our role. So Mac, you want to talk about, we left that title slide up quite a while, so we took a little of your thunder.
But I don't know how many of these people actually saw that title slide.
There you go. Talk a little about Q&A and what you would recommend we do today with our conversations.
Well, I'm actually really looking forward to this, not only to delve deeper into the Axient Digital tech side, but also kind of hoping that Michael and Dr. Kenkel can talk a little bit about Shure's recent announcement of their partnership with Quantum on some products, which I find also exciting. But to get past that and into what I'm supposed to say to you, which is about Q&A, if you didn't see the note on the bottom of the title page, to ask questions, you go to the question pull down on your GoToWebinar control panel, and there will be a place to write in your question. please be specific about your question because it will not be answered immediately. And when it is answered, we may not remember what it was you were responding to or asking about if you don't specify in the question. But we will try to get to all the questions, or certainly all the topics, if we can't get to everybody's individual question. And that's it. I think you all know the drill, because there's an awful lot of familiar names over there on the attendees list. So I think you've all heard that silly spiel before, and I'm looking forward to hearing from Michael and Mark now. So Pete.
Well, with 100 people actually logged on, we got one question already. Great. Thanks a lot, Dan. I figured we'd have at least 10 or 15 by now. One thing I wanted to point out is don't want to forget that Monday we have terrific smart presentation, and Wednesday on my lunch, we're doing the how, wow, where, when, what of Part 74. We're going to teach you all how to get your license and why you have to get your license and how you're going to use your license and all that sort of stuff. So there were the days when, even though you had to have a license, nobody ever did. But now I think it's important for people in this business to understand, if you want to use the stuff up in the 600 band that's open, you've got to have a Part 74 license. If you want to take an Axient Digital and actually put it on top of a digital TV station that happens to be weak, you have to have a Part 74 license. So I've loved Axient Digital from the second it was introduced, because its solution, it is the solution to the disappearing spectrum. And with that little bit of expectation, go ahead, Michael.
Well, first, thanks, Kelly, Mac, and Peter for the great introduction. I really appreciate it. I also really appreciate the opportunity to be on the other side of these calls. I've been joining many of the calls and webinars that you guys have been doing at Practical Show Tech since we've been staying at home, and I know I could speak for everyone at Shure that we've been watching them and we've been getting a lot of value out of them. So I just wanted to give you guys a quick shout out and thank you for all you've been doing for our industry during this time.
Thank you.
Oh, thanks.
Well, that's a great question.
So what I wanted to do is I wanted to start a little bit by just telling you who we are and at Shure and what we do. Here today, I'm joined by Dr. Mark Kenkel. I'm Michael Johns. I'm the product manager for Axient Digital. I've been at Shure going on 20 years now. Prior to working on Axient Digital, I worked on PSM 1000, PSM 900, and PSM 300. So pretty much all of our current PSM products. I also worked on our headphone category before that, and I've been spending my last several years working in the pro wireless space, and see a lot of familiar names on the attendee list today. So hello to all of you, and look forward to meeting the rest of you folks in person sometime soon. So Dr. K, would you mind giving us a brief introduction about yourself?
Sure. My name is Mark Kenkel, and I've been at Shure for about 28 years. Working on all things RF and wireless. It's an interesting picture you chose of me, MJ. I think that one was taken at the Super Bowl
photo
during the when we first introduced UHFR. So when I started at Shure, we only made L series, and everything was single frequency crystal controlled. And so it's been just amazing to see the evolution of wireless microphones over the last 28 years. It's a completely different world these days.
Yeah, I'm really happy to have you on the call today because, as you mentioned, you've been at Shure such a long time, and you've worked on UHFR and so many of the original U series and so many of the legacy products that many of our attendees use and rely on over the years as part of their tool chest, if you will. So I'm looking forward to some of the questions that we get and you having the opportunity to answer them. So thanks for joining us today.
No problem.
So what I wanted to do today, and we definitely will spend a great deal of time going deep on the 2 feature sets on Axient Digital. Actually, we're going to talk about 3 things today. We're going to talk about Quadversity mode, how you might set that up in a distributed antenna system, and philosophically how it works from an RF standpoint. We're also going to be talking about frequency diversity and how that works operationally, as well as some use cases on how that might get set up. Between each section, we'll encourage you guys to ask questions. So Kelly or Peter or Mac might break in to ask the questions that you guys come up with as we go through the presentation. And I'll also cover a little bit of information about spectrum management too, and how our interference avoidance works. There's lots of ways you can operate a spectrum manager. You don't necessarily have to rely on wireless workbench to automatically deploy frequencies, and I wanted to share just a little bit of the flexibility that we have with interference management as well with you all today. But we're going to start with just a little background on Axient Digital. I know some of the folks on this call are really familiar with Axient Digital, so this might be a little bit rudimentary, but I think that for a lot of you folks, it'll be interesting for you all to see Shure's perspective on where we see this product and how it compares to everything else in our portfolio. So, when we decided to develop Axient Digital, it was right around the time when the 700 megahertz auction was taking place, and there was this big fear of white space devices and them encroaching on our wireless microphone spectrum. There was a lot of ambiguity about how the future of RF would actually be based on that 700 megahertz auction. And to address that, we came out with Axient Analog. The whole premise of Axient Analog was robust RF, great audio quality, but also this idea that a wireless microphone could avoid white space devices and other interferers that may just pop up dynamically, because as many of you may know, at one point in time, we thought that every user of a handheld would have a white space device operating on the UHF spectrum. That turned out to not really happen. But that was a big concern and the reason why we developed interference management. As it turns out, there were other reasons why interference management became really important, mostly because of the combination of decreasing spectrum available around the world, certainly in the United States. That is the case not only with 700 megahertz, but with 600 megahertz as well. The fact that more and more wireless microphones are being used than ever before. I remember going to shows 15, 20 years ago where, if you saw 15 or 20 wireless microphones, that was a pretty big install. Fast forward to Lollapalooza held here in Chicago last summer, where there was, I think, the RF coordinator was coordinating upwards of 500 wireless channels over 8 stages. So our industry has changed, the spectrum has changed, and that requires products to just operate even more reliably and spectrally efficient than ever before. So we wanted to take all the benefits of digital systems, their linear operation, their great audio performance, and to combine it with the hallmarks of Axient, which was all of those things I mentioned, most notably interference avoidance and remote control. And that's how we came up with Axient Digital. So Axient Digital is a replacement to both our analog UHFR and our analog Axient series, but we do that with one receiver platform. What I'm showing here is the quad receiver, the AD4Q. We also make the AD4D, which is a 2-channel version. Since we're talking about Quadversity later on, I'll mention now, Quadversity is a feature only available on the quad receiver. So if you have a dual receiver, you get all the features of Axient Digital with the exception of Quadversity. And that'll become a little bit more clear as we go through the presentation. So AD series is our upgrade path from UHFR. It's a digital radio, great performance, but no show link. And that's really what distinguishes our replacement of Axient versus UHFR. The ADX series transmitters not only have show link, which for those of you that don't know is what we call our remote control between the transmitter and the receiver. And so these transmitters not only have show link, but they have some pretty unique form factors, as you can see there. Some of you might be familiar with our microbody pack. It's the first wireless transmitter on the market to have an internal antenna, certainly for the pro audio application. The handheld that we're showing there is the ADX2FD. That's a frequency diversity transmitter. And another topic of our discussion today, that transmitter, as small as it is, can actually transmit 2 discrete frequencies simultaneously. So in addition to the Axient upgrade path being ShowLink, it's also these unique form factors. And I'm sure you all can think in your minds of some unique applications that these form factors might enable: theater, broadcast, on TV talent type applications, those that are not wearing a whole lot of clothing while wearing headsets on stage, like female singers and that sort of thing. So lots of flexibility with these 2 platforms, all available with one receiver as the receiving point. So, going over this slide might seem a little bit obvious, but we'll talk about this within the context of Axient Digital. To me, these are not only the core pillars of Axient Digital, they're the core pillars of any good RF mic system. One is the RF has to be good. Without good RF, it doesn't matter how good the audio quality is. We have to actually deliver the audio payload reliably before a user can even enjoy that audio itself. So the first hallmark and the aspect of Axient Digital we spent the greatest deal on is its modulation scheme. And that's what yields such high RF performance. And some of you might have encountered that. I like to talk about a demo that I did a couple years ago in New York, in Times Square at the PlayStation Theater, where we put two antennas out and on the marquee, and we did a walk test, and we're able to walk that microphone about a block or a block and a half away in downtown Times Square. And that for me was during the development of Axient Digital, and we had invited a special group of guests in order to do that. And that, for the first time, I actually saw this product in a real world scenario do what I thought at the time was the impossible. So we're not the only great sounding digital microphone out in the marketplace, but I'm really happy with what we did RF wise and what we did with that modulation scheme. It's a proprietary scheme that uses some patented technology in order to keep the RF link as good as it is.
Michael,
but of course,
I think you're underselling that demo in the theater there. We were in a theater halfway between Broadway and 7th Avenue, and the 2 antennas on the marquee were connected by 72 ohm video cables through the building.
right.
And a handheld walked from the stage of that marquee out to the street, all the way down to Broadway, which is about 250 feet, turned right, and started down Broadway, out of view of the antennas, and got all the way from 44th Street to almost 40th Street before the audio dropped out. Quite amazing.
Yeah, I'm glad you reminded me of that. At one point, we had several engineers on hand. We had no direct line of sight, and we were actually getting mostly reflections off of buildings. And Dr. K, as we go through Quadversity, he can describe our lineup and how the detectors work and how we can benefit from some of the technologies that are in Axient Digital that enable walk tests like that. So thanks, Peter, for mentioning that. The next thing I wanted to talk about is command and control, an important aspect, especially today, right? With COVID-19, people are going to be limited in terms of the spaces that they have access to, but we're still going to want to have people that are able to monitor the wireless microphones. And so products like Wireless Workbench and our channels application, which I'll talk about later, allow that. And what they allow is remote command and control of your transmitter or receiver. And we've had that for quite a while with our ShowLink technology, and we're expanding on that with software, with Workbench, and with channels. And we're going to continue to do that because, as I mentioned, Shure sees that as one of the core 4 pillars of Pro Wireless. And the final one is hardware and scalability, right? When a company develops any product that operates on, like, say, rechargeable batteries, for example, there's always a trade-off that you have to make. We can design the optimal size and shape for the user, which may require a new unique battery, which within itself is quite an exercise, working with the supplier to have a unique battery form factor. And And sometimes users need that, and sometimes users prefer to have a common battery that would work across the entire platform. And so that hardware and scalability kind of plays out with batteries, looking at Axient Digital. The 80 series transmitters all use the SB900 series battery, which work on ULXD, QLXD, PSM 1000, PSM 300, PSM 900, and other products as well. So P9HW, so it's a platformable battery. A studio, a broadcaster, a rental company can just standardize on that battery, and they know that all the Shure products that they have can operate on that battery. But in the 80X series, we chose some unique form factors. Like I mentioned, our micro body pack obviously couldn't work with an SB900 battery because we wouldn't have been able to achieve that round shape that we achieved. So we try to keep as much hardware and scalability between our products as possible in a way that we were able to do that. Using my battery analogy and taking that a bit further are the chargers that we have. They're all networkable. You can use our SBRC rack mount chargeable, which I'll show you in a moment. And it has plug and play modules. So if you're using some 80X series and some 80 series, you can specify the modules to come in a way to where you can charge whichever battery type you happen to own. And that's really important to us. We don't expect our users to invest in new battery platforms every time we come out with a new product. And we're sensitive to the fact that that battery standardization and standardization of platforms is really important. And that's something that we definitely tried to do with Axient Digital. And I'll talk about some of those aspects in my next slides. So here's the receiver. A lot of you are probably really familiar with this front and back panel. So I want to go a little deeper and talk about some of the things that you see on this front panel and what they actually mean. So we have a meter on our front panel called the channel quality meter. The channel quality meter is a little different than an RSSI meter, right? These two LED stacks, if you look at channel 1 and you see A and B, those are RSSI meters, which are relative signal strength and indicators. They measure the RF level in dBm, and they're indicated in this LED stack here. What they tell you is how much RF energy is present at the input of this receiver channel. So in the case of channel 4 here, it's a 607,500. We have full bars here of energy coming in. But what we don't know at this point is whether or not we're tuned to a DTV station or not, right? If you take any analog receiver and you tune it on top of a DTV station, the RF lights light up, obviously, because it's telling you that there's energy present. It's not telling you whether or not that RF energy is desired or undesired. It's just there. And that's where the channel quality meter is really helpful, because the channel quality meter actually can indicate to the user what their link margin or what their RF signal to noise is. Because in a digital modulation scheme, you can send more than just an audio payload over. In this case, we're sending over a bit that can be measured. And this is how all wireless, digital wireless companies present a link margin or channel quality metric. Is we have a bit, we know how clean it should look. We can measure the noise around it, and we can report that in their channel quality measurement. So if you're looking at a receiver and you see that it has 5 bars of channel quality, that means you have at least 30 dB of link, which is really good. That means your signal to your noise floor on the channel you're on at that moment in that location is at least 30 dB. And the bar and the numbers scale appropriately to where when you're on 2 bars of channel quality, you have about 12 to 10 dB of link left. That's really close to a dropout in most situations. So the channel quality meter, along with the RSSI meter, really give you deep, detailed information about the link in the channel that you're operating on at the time.
It's kind of like getting a message that like let's say you periodically sprinkle a message that says everything's good, everything's good, everything's good, every good. Occasionally that message doesn't come through. Well, and if you got 4 channels in it and 3 of them are telling you everything's good and one of them's kind of stuttering, that one's maybe the one you don't want to use.
Absolutely. So I'll skip diversity and quadversity because we're going to talk about that later. But high density mode is a feature we're really proud of. And I have a couple slides at the end of this presentation that actually show our standard mode and high density mode operating on a spectrum analyzer. And so you can see that in standard mode, we operate 17 channels in a 6 megahertz wide TV spectrum, but in high density mode, you can get 47 channels on air. And the way that we do that is a combination of a couple things. We use a different codec, we use a slightly different modulation scheme, and we operate the transmit power at 2 milliwatts. By doing that, we change our spacing from 350K to 125K, which essentially more or less triples the amount of channels that you can get in a swath of bandwidth. So in applications where you can run the transmitter at low power, and keep in mind these are digital radios, so 2 milliwatt of a constant power digital radio might, we feel like our 2 milliwatt mode is kind of comparable to 10 milliwatts in UHFR. So if you're comfortable with doing that, you can use modes like Quadversity, add antennas to add to your receive side sensitivity to get some of that link margin back. You can use high density mode, and we have NBC, for example, they're using a version of high density mode that gives them the ability to operate tons of channels in a single UHF TV band. And they have a tough challenge being in Times Square and having so few DTV channels to operate with so many different studios. Of modes like high density mode are key. Another one, a lot of you guys might be familiar with the David Byrne tour. David Byrne's been touring all over the country and all over the world with an ensemble of musicians, including like 20 or so people that play African drums. It's really a beautiful thing. He's got these strings and drum instruments all on stage together. It sounds like it's tracked. It's that good. And they're using wireless microphones for every instrument. So they're using little body packs connected to all sorts of African drums, because these people have to move around on the stage during the show. And so in order to do that, they have many of those channels in high density mode, because there was no other way to get that many channels into all of the places that David Byrne plays. So high density mode, another key feature on Axient Digital. In terms of the audio quality,
let me just pause you 1 second.
Sure.
Question just came up. Can you run HD mode and standard mode in the same RF space?
You can. You can't operate them in the same receiver though. So for example, if you wanted to run channel 1 and 2 of your receiver in standard mode and channel 3 and 4 in HD mode, that's not possible. It's like the whole box operates in HD mode. But in terms of your wireless spectrum, absolutely, you could take one receiver in HD mode, that's 4 channels, another receiver that's in standard mode, that's 4 channels, and Wireless Workbench will coordinate spectrum for all of it without a problem.
And they can be intermixed, a bunch of high density and a bunch of regular.
You have to have the Workbench do the coordination for you, because the high density mode does put them right next to each other and ignores intermodulation.
Right.
And you can do that because you're running at 2 milliwatts.
Right.
But when you're in standard definition or standard mode, you need to coordinate with the third order intermods.
Right. But they can be sort of close to or intermixed.
Oh, sure.
Okay, cool. Thank you.
As long as they're coordinated, right?
Right.
And so yeah, talking about audio quality, to me, it's a little bit superlative. We really tell people, listen to it. We'll bring a demo system, or we'll ask you to go to your local, dealer and ask you to try it, because frankly, our digital audio, we feel it sounds like a wire. It doesn't really sound like an analog wireless system at all. There's a clear difference between UHFR or Axient, excuse me, and an Axient Digital. And that's largely because of it being digital and because of the codec that we're using. And, codecs for a time in our industry were kind of dirty words, but every wireless microphone manufacturer, if they're making a digital solution that can operate with multiple channels on air at the same time, they're almost always using a codec. And frankly, I'm really proud of our industry as a whole. Not only us, but our competitors as well have made some really good sounding digital systems. And that's good for us, because what it's proved between us and Sennheiser and Electrosonics with their IEM and everyone else is that digital radios can sound really good. And the word codec, it doesn't necessarily, people hear codec and they think of MP3s, which are lossy codecs, right? But a lossless codec encoded for a specific application like an air interface like Axient Digital can sound as good as a wire perceptually. And that's an important distinction that I like to make between these products and the legacy analog products. We operate at 2 milliseconds of latency. That's in standard mode. In HD mode, that number goes up to 2.9 milliseconds. Those are really low numbers, and that's from the capsule in to the analog out. Depending on the digital interface you're using, you may gain latency, but you also may reduce latency, right? Because you have a D to A conversion going out analog that will add a little bit of latency. Of course, if you're going Dante and you're using the standard 1 millisecond buffer, you lose a millisecond. But depending on your digital configuration, if you're using AES3, for example, you can get your latency measurement a little bit below 2 milliseconds because you're bypassing that final D to A at the output. But 2 milliseconds is a general rule of thumb number we like to go with when we talk about our latency. And again, 2.9, so just below 3 in high density mode. We have all sorts of outputs on the back of this receiver that you can see. We have Dante, we have AES3. Of course, over the Dante port, we can also do AES67. And we have good old analog too, which I realize we didn't even put in the stack. But yes, it does analog too. And you can actually use all 3 formats at the same time. You can get, Dante primary and Dante redundant out to 2 different places. You can run AES3 channels 1, 2, and 3, and 4 out of the XLR ports. And then you could still get analog out of the 1/4 inch ports on channels 1 through 4 as well. So there's a lot of flexibility in terms of audio routing right out of the back of the receiver. You can literally use all 3 outputs at the same time if you want.
What do the unused outputs 1 and 2 XLRs do when you're in AES3 mode?
That's a really good question. They go dark, but the 1/4 inches still work. So you get, 1 and 2 out of output 3, and 3 and 4 out of output 4. And then outputs 1 and 2 go dark. We've maybe thought about putting a copy of AES 1, 2, and 3, 4 on this end too, but that's not the case. And then finally, we have, we have all sorts of flexibility between our receivers and transmitters. The transmitters tune as wide as the receivers do. And in the US, the primary band that we operate in, and I have a slide showing that in a second, is from 470 to 608. So our transmitters and receivers all tune to that range. There is no mixing and matching transmitter bands based on receiver bands. It's all one wide range. And of course, as I mentioned, AD and ADX are all intermixable and intercompatible with one another. And it builds on the Shure ecosystem. It works with Workbench. Some of the it works with our Spectrum Manager, which worked and was developed for analog Axient. It works with our AXT 610 access point, which is our old access point, and it works with a variety of rechargeable batteries, as I mentioned. So it builds upon a bunch of components that Shure has already had and developed long ago. So on those frequency bands, and I'm glad Peter mentioned license operation, because some of what I'm showing here is incumbent on you having an FCC license. So for example, if you look at the A band, you can see that in the A band, we have 2 ranges that we operate in the United States and in Canada for that matter. G57, which operates 470 to 608, and then G57 Plus, which operates 470 to 608, and it also operates in a gap band 614 to 616. So this gap here between 608 and 614 is radio astronomy. That's channel 37, I think. And that's a radio astronomy channel. It's blocked out globally, or at least in the United States. But we have this little 2 megahertz on the back end. But there's a little asterisk here because unfortunately, our partners at the FCC didn't allow frequency diversity operation in the gap bands. And the gap bands are 614 to 616, 606 to 608, and 653 to 663. So these are bands that you can operate in the US as long as you have a license and as long as you're operating at 20 milliwatts or lower power. And as long as you're not using Shure's frequency diversity handheld. So that's why we have a G57 and a G57 Plus. G57 Plus is basically for all Shure transmitters except the frequency diversity handheld, which only operates in G57.
Can you use ADX transmitters if they don't have automatic, if you don't use them in automatic mode?
Oh yeah, absolutely. Yeah, a lot of people use them exactly that way. Like take my example of NBC, for example. You know, they have a pre-coordinated frequency list, but they're using a lot of ADX. They just don't use the interference avoidance mode. They just use them for obviously their form factor and for their remote control ability. So they can go in and they can see status and change them if they want. So the B receiver, and by the way, these bands that are not red are the various frequency bands that work all over the world. So just an example, G53 is Hong Kong, H54 is Australia. So if you were to take this receiver on the road and say in a touring scenario, you're working with someone who goes to Australia, you can just rent the transmitters locally. You just take your receiver and tune it to H54, and then everything in the rack can still be configured the same way. You would just show up with locally and then get the transmitters only. So that's a helpful thing that I think a lot of people don't realize. But of course, if you're in a fixed install, you would just use one of these bands.
Does each of these frequencies, 53, 54, 55, 56, 62, 54, require a different transmitter model?
They do, yeah. So you can tune, like right now, you could walk up to an Axient Digital receiver and you could tune it to, say, H54. But unless you have an H54 transmitter, which you shouldn't unless you bought it in Australia, it wouldn't work. So the point is that, if you're with, I don't know, you're with Celine Dion and she's using G57, and I'm just using her as an example. I don't know if she even uses Axient Digital, and she uses G57, but then she goes to Australia. Her sound engineer wouldn't theoretically have to bring the transmitters along. I mean, he probably would bring them along, but instead of having to rent a whole kit, in Australia he would just rent the transmitters.
So the red ones are US, is
yes,
what?
Yeah.
Okay. The rest of them are okay.
Yeah, so these all have different countries. JB's Japan, R52's Israel. So this is an interesting rubric of frequencies around the world. So the C range is something, or actually let me focus on the B range for a moment. The B range works in the US in these three ranges, and it's sort of like a mystery band that a lot of people aren't aware of. If you have an FCC Part 74 license, you can operate in these three ranges. And most places I go, they're pretty clean. So, this is 2 megahertz here, 2 megahertz here, and another 10 megahertz here. That's 10, 14, that's 16 megahertz. That's a lot of Axient Digital channels you can get on air in spectrum that in most cities is pretty clean. Of course, I don't guarantee that. Do your scan wherever you go, your pre-coordination and site survey. But generally speaking, these ranges are pretty clean most places. And if you have a license, investing in the B band isn't such a bad idea. But of course, you lose that wide tunability that you get with the A band in UHF. And then finally, the C band. Peter was mentioning licensed operation. That applies with the C band as well, and with this band that we call X55. X55 works 941 to 960. It's the new STL band. STL used to be 944 to 952. And then as part of the auction, it got opened up to be 941 to 960. So if you are an FCC Part 74 user and you pre-coordinate with the SBEs, the Society of Broadcast Engineers, from what I understand, they assign a coordinator in each major city. who sets up all the STLs, you can use the STL band. And it's a band that it's pretty wide, 19 meg wide, and in most cities you might find 2, 3, maybe 4 transmitters on. So lots of available spectrum, at least in my exploration.
So we did have a question if you were going to have a DME band, which is wider than your X56, available for outside the United States. The answer is yes.
Yeah,
960 to 1215.
Yeah, so we're doing that in Axient Digital by offering something that goes from 960 to a gig. So we don't operate in the entire DME, but we're operating in the first 40 meg of it.
Terrific. There were a couple little questions from the prior section you were on,
Sure.
which we ought to cover. With digital transmission, does the audio level still affect the wireless transmission range, similar to analog and digital hybrid transmissions?
It doesn't, but I'll let Dr. K elaborate.
Yeah, the range is not at all affected by the modulation because of it's a digitally encoded RF signal. So what you're getting is encoded into the amplitude and phase of the RF level, and then that's converted into bits. So
what's the dynamic range of the system? Let's say you can get a pretty good signal even if somebody's just whispering into the mic and you're not moving the meters on the front.
oh yeah, I mean so the audio dynamic range and the RF link are completely separate. So if you want to whisper, go ahead.
Yeah.
It's
Any downsides to encrypted transmissions like battery life?
No. I guess if you want to consider one downside, there's a one-to-one relationship between the transmitter and the receiver because we pass that encryption key over infrared. So you couldn't have a combo situation where maybe you had, a CEO that used a handheld and a headset, depending on what part of the presentation. If they wanted an encrypted link, you would use 2 dedicated receiver channels. But
it still is frequency controllable, just has to be locked by infrared.
Yes, and it basically locks one transmitter to one receiver,
Right.
One receiver channel, which is kind of the point, right, of encryption. But
Right.
no change to audio performance, no change to latency.
right.
To
It
the
links that
A1, you don't know
transmitter
the
and
difference.
receiver.
Right.
So one transmitter, one receiver they're linked together, but then they can change frequency.
Right.
They still remain linked.
Exactly. Yeah.
But isn't a paired wireless mic locked to one receiver anyway?
Well, you could pair it to more than one receiver.
Or are you saying that the encryption is hard coded into one receiver and one mic? You can't change it.
You can. So say you had a transmitter on encrypted to receiver channel 1.
Right.
You could then sync it to receiver channel 2. The receiver just kind of passes the key over from channel 1 to channel 2. Channel 1 loses the encryption and channel 2 gains it. So think of it like passing a key, right? Like literally a key.
So it's the transmitter that you buy as an encrypted device.
Yeah, well, you put the receiver in the proper mode, and then when you sync the transmitter to the receiver, the transmitter gets the key and then holds on to it.
When you first pair the transmitter to the receiver to allow it to remotely control it, you're also syncing to a specific channel.
You are, yeah, but that doesn't necessarily prevent another Axient Digital receiver. Like, let's say in that scenario, someone else has another Axient Digital receiver. If it's an Axient Digital receiver and it's tuned to the same frequency,
got it.
It's going to pick up the audio.
Wouldn't keep them out, right?
Right. The only way to keep them out is to have that encryption key.
Mac?
I was just going to point out that, like Zimbal just mentioned, that you couldn't then use two receivers, like a receiver for stage 1 and a receiver for stage 2.
Oh,
So you
okay.
couldn't do encrypted that way because it's
Got it. That makes sense.
one receiver to one transmitter, the encryption key.
Yep. Okay.
Correct. Right. That's true. Hi, Ike, by the way.
Another question, does the word clock in and out link back to and affect the ADCs on the transmitters, or are the signals reclocked within the receiver? He's asking, does the word clock actually sync the transmitter, or is that just a reclock within the receiver?
Talking about the receiver word clock?
Correct.
The audio, that syncs audio, right, from the receiver to
Right.
whatever
It is
connected
to
device.
do with
It has nothing to do with the transmitter.
Digital
right
entry.
now.
Right.
Okay. Jeff was asking, he asked a question about HD mode units and standard mode units in the same room or zone, but then he asked another question. So put HD in one TV channel and standard in a different TV channel, or can they be in the both same TV channel?
Sure. Yeah. You can go into Workbench. You could create an exclusion so that exactly. You can create an exclusion so it only puts things in, say, TV 21, and you can see how many HD and non-HD channels it can fit in that 6 megahertz exclusion or 12 megahertz or whatever your exclusion range is.
Right. Asa Kelly asked, we currently have 4 channels of UHFR in the football stadium, receivers and antennas in the press box, transmitters on maximum power. He'd like to go to Axient Digital. Will Axient transmitters still have the power to hit the press box antennas from throughout the field? I think even more.
Yeah, the really truthful answer, especially with Dr. K watching me right now, is it depends. I can't guarantee it. It depends on the RF environment, the cable that's installed. But I'll tell you this: I think 30 of the 32 NFL stadiums right now are using either Axient Analog or Axient Digital. I think that's the right number. It's definitely the majority of NFL stadiums are using Axient or Axient Digital. There's a big Axient Digital install at University of Notre Dame. That's an 80,000 seat stadium. They put their antennas at the press box, and they have referees from the major sports conferences running up and down the field without a whole bunch of issues. We do, in those applications, recommend you operate in high power mode, which in AD series would be 35 milliwatts. In the case of ADX series would be 40 milliwatts.
I tend to not even look at the RF level. I watch the quality of service and the 2 blue lock lights. If I've got those lock lights on, I'm home free. And particularly if I'm running in Quadversity mode, that's great.
Yeah, and I think we fully answered that question, but just to elaborate on it a little bit, the actual RF sensitivity of Axient Digital is so good that you'll find situations where you may only have 1 bar of RSSI, which means, I think that means you're at minus 90 or 95. Yeah, minus 90. And then you'll see that you have 4 out of 5 bars of channel quality. That's okay. That means you have at least 25 dB link margin even at that input RF input level. So I guess that means
two other questions. Jeff Jones wants to know, are the 1/4-inch output at a different level than the analog XLRs? They're marked right in the back -10. So yes, they are at a different level.
They are. Yeah.
And can AD and ADX mixed on the same receiver? The answer, I think, is yes, because all the difference is the ADX will be remote controllable via your access point.
Exactly.
In the H54 example, can you use a US transmitter but keep it within the H54 area? Well, if you're using a US transmitter, why not use the US band?
I mean, theoretically, you could, if you were to take our receiver and put it in, it has different modes. So block mode is kind of what you were talking about earlier, Peter. If you put an Axient Digital receiver in block mode, that says, I'm only going to receive signal from a transmitter that has been synced to me. I don't care if it's you know, if I'm tuned to 470 and I see an Axient Digital transmitter at 470, if it hasn't been something that's synced to me, I'm not going to receive it. That's not encryption. We have encryption as well. That's what we call transmitter registration. The difference between a non-registered transmitter and an encrypted transmitter is that the signal over the air is actually being encrypted by AES 256, standards.
Right.
Whereas transmitter authentication is not.
Right.
It's just identifying a link between a transmitter and a receiver.
And if you're on a tour with your G57s and only use 520 to 608 in your system, you're still legal. You don't have to use the H54 band, right?
Yeah, but in that example, if you wanted to use H54 for whatever reason, if you put the receiver in allow mode and then you tune the transmitter to say 520 and then tune the receiver to 520, it would pass audio.
Right.
It would. But you would lose a lot of the additional features you get with transmitter authentication. It's certainly ShowLink would.
Well, no, actually, I was asking if you're touring with an American system in the G57 band, but limited your use of that band to 520 to 608, which is all you could do, it would be okay with the people in Australia. Or did it have to be type approved for their system?
That is correct.
That's a good question. Yeah, they may frown upon you using a transmitter that wasn't approved in their country.
Yeah.
Right.
Talking to two people that represent a manufacturer, we're going to tell you to check with the local regulator first. Don't just show up with a transmitter that you think might be legit. If you bought it in the United States, if it has an FCC a sticker on it and not a CTIC sticker, which I think is the regulatory body in Australia, then it's probably not legit. It's at least worth checking with your local rental company.
Is the X55 band what we call the X band in the United States?
Yeah. Yep.
So that requires Part 74 license.
Oh yeah.
Okay.
In fact, Shure will not sell you one unless it's without sales manager approval. So generally, the dealer account or the end person has to be verified as an FCC licensed user. Otherwise, we are not authorized to sell it to them.
Right. Henry Cohen says, are you going to discuss required CNR to keep BER, FER constellation stable? Obviously, those three-letter words mean something to you, not to me, but.
Yeah, so, I mean,
what do those three-letter words mean?
Well, BER is bit error rate.
Okay.
What were the other? Constellation, he's talking about the way digital modulation scheme actually looks on an analyzer, right? It appears like a constellation.
Right.
And when that constellation looks noisy, it doesn't have clean points. It has like fuzz around the points.
Fuzzy dots.
And that's an indicator of having a high bit error rate.
So your quality of service will be lower.
Yeah, so basically, if your channel quality is low, the bits are going to look fuzzier in the constellation. They're going to be off center, and they're going to not be round little circles. They're going to be modulating.
What does DNR stand for?
DNR.
DNR.
Oh, carrier to noise ratio. I'm assuming, which is that's a signal to noise ratio. Same thing.
So what is the CNR required for Axient Digital versus ULXT for operation?
So I don't know if I could speak in absolutes on that one without maybe being misleading, but I know that, Axient Digital operates okay with about 15 or so. And our channel quality, I think that last pilot bit goes out when we're below. I'm sorry, that last channel quality meter goes out when we're at below 10 or 12.
Yeah, I was going to say 10.
Yeah. So I'm not sure how that compares to ULXD because there's so much more going on there. It's a switching diversity system. So
10 dB carrier to noise is kind of equivalent to like where you would get 20 dB SINAD. and an analog system. So,
Right.
so in that way, they're comparable, except in the digital system, the audio sounds great right up until it doesn't.
Right. Yeah.
And the last two, for John Christie wants to know, there are some, or he's stating, there are some countries, read as Canada, which allow some operation from 902 927, but has not yet opened up 941 to 960. Is there any chance you could create another RX C-band that goes lower in the spectrum? Going higher doesn't help us on that side of the border. In other words, the DMC.
I mean, anything's possible. The receiver tuning range is 750 to 960.
Right,
So
right.
the hardware is capable of it.
Right.
John Christie, send me a text. We'll talk more about it.
Encryption doesn't have anything to do preventing interference on that channel. Yes, or
No.
if you have something on the same channel, it would just turn off the audio. If
Yeah.
you have a the same mic on the same channel, higher power, it would just turn it off.
Yeah, Dr. K, you want to?
Well, there's a point. If I can decode my signal in the presence of the interferer, then your audio will still come out. It won't turn anything off. It's when the interferer is to the point where I can no longer decode my channel, then it would mute the microphone. And that would be regardless of encryption is on or off.
Yeah. That's the same true if I have two on the same channel, as long as one is 10 dB hotter, that's the one that's going to come through.
Right.
Right. Now, he said, another person who I don't have his name yet, he'd like to know if Shure is planning for WWB6 to control two or more receivers with the same frequency. I don't know if it's limiting you to have the frequencies at all. I think it'll let you put them all on the same frequency if you want to.
Yeah, I suspect that this question,
multiple receivers from one transmitter.
Yeah, I mean, this question might be more related to whether or not in a show link scenario, one receiver can sort of slave to another receiver.
Right.
So like a parade route application where I'm using a show link enabled transmitter, with connected to one receiver when I'm near Mickey Mouse Land, and then another receiver when I'm near Cinderella's castle or whatever. How does that show link work? Is probably the question. And right now
you can
it
do
doesn't.
that if you're not encrypted.
You can, but show link.
He's wondering if WWB6 will allow you to have multiple receivers in the coordination with the same frequency. It'll probably give you an error because you have the same frequency.
Yeah. Oh no, it wouldn't. Yeah, it would not.
Well, there's zones in Workbench.
If
you put them in different zones.
Yeah, that's true.
Even so, it would probably give you an error because they're the same frequency. But on the other hand, it wouldn't prohibit it, I don't think.
No. If they're in different zones, then they would be considered, like each coordination is considered separate from the other.
I don't even think it'll tell you there's an error if you put them in different zones.
Even when they're in different zones, they still need to be separated technically, so it would prevent it. But one last question: does the encryption key change after each registration?
Yeah. So I assume that means that that question is each time it's synced, and it does. Yeah.
Right.
To some random encrypted value, I'm sure.
So go ahead before anybody asks another question, quickly.
Yeah, well, this will be fast anyway because a lot of these folks are familiar.
Get to the Quadversity part.
Yeah, so we have a AD series. We have actually two different body packs. There's one with a LEMO on it. I'm just showing the TA4 here. It uses either AA batteries or it uses our SB900 rechargeable battery. And then the handheld works with all Shure capsules. It works with a bunch of third-party capsules that use our mounting scheme. Comes in either black or a brushed nickel. The biggest difference, these look a lot like ULXD from a form factor standpoint. The big difference is ULXD had a switch right under the bezel, and we put our power switch on the radome for Axient Digital. But if you're familiar with ULXD and not Axient Digital, if you open up the battery door, it kind of looks similar. So here's the ShowLink stuff. In order to operate ShowLink, you need one of these transmitters. And here we have the ADX1M, which, as I mentioned, is the first pro audio body pack that I know of in our industry that does not have an external antenna. Not only does it have an internal antenna, it has a self-tuning antenna. So if we get questions about that, Dr. K and I can address it. We have the ADX1, which is a ShowLink body pack. Can either use 3 AAA batteries in a sled, or it can use Shure's rechargeable battery SB910. And then we, of course, have the handheld with the same mounting type as the AD series. Comes in either a single carrier or a FD version, which is 2 radios that are transmitting 2 different frequencies. And the access point on the far left. The access point is required for remote control. And so the way remote control works is you have an access point that's physically connected to the receiver's network somehow over PoE. It could be direct, it could be over a switch, but somehow it's connected to that receiver's network and is in, quote, the field of play. It sends a 2.4 signal to the transmitter, and the transmitter sends those 2.4 signals back to the access point. The access point carries all that data over Ethernet to the receiver. So that's why you need this access point. It's basically the radio, the ShowLink radio over Zigbee that connects the receiver to the transmitter. Of course, the UHF audio comes over these various antennas directly to the receiver's UHF antennas. So here are those battery charging solutions. The 240 and the 840, that's either a 2-bay or an 8-bay charging solution. We designed the 840 so that it would fit in a 1 RU drawer nice and easily. The 240 fits in a 2 RU drawer with no transmitters in it. And you can also put batteries in these as well. So when you put batteries in these, they will fit in the 2 RU drawer. It fits really nice for side by side. The SB840M is a tabletop charger for the special battery we use in the micro body pack. And the SBRC is the battery charger I was telling you folks about. All of these modules are plug and play. So here in this image, we have going left to right, the module that holds the SB900 batteries, the module that holds the micro batteries, the module that holds the ADX1 batteries, and then the module that holds ADX2 batteries. So this is basically demonstrating the whole Axient platform can be charged with one station. And these are fully configurable. You buy the SBRC and the modules separately. So you would pick the modules based on the number and types of transmitters that you have. So talk switches. We have 2 different type of talk switches that we have for ADX transmitters only. These don't work with AD transmitters, only ADX. We have the 8651 FOB, that stands for fob, is in like your key fob. And that is primarily for body packs, although it could technically control messages on a handheld as well over Zigbee. This is the ring talk switch that goes with the handheld. Here's a picture of it assembled on the handheld. This button can be configured to do a lot of things. It can be a mute. You can select different output routings. So for example, I can tell the receiver when this button is pressed, mute the XLR audio and pass the 1/4 inch audio. So you can use this button for routing to production versus to broadcast, for example. We have some artists in Latin America, particularly really big pop stars, that use the talk switch for call outs. So, you know, he'll sing into the microphone, but when he wants to talk to the band, he'll just press the talk switch that mutes the house, and that sends the signal to all the band's in-ears. So he can press that button and say, okay, we're gonna play, you know, whatever song next, or use it to communicate with the band in a variety of ways. So lots of flexibility. We also have something called TPCI commands, which is our third-party control interface. And you can set TPCI commands based on a talk switch. So our friend John Christie, actually, who asked a question, set up an Axient system once where when you press the talk switch, it actually made like a little light go off on the receiver rack, I think to let people know that the button was being pressed. And that was all done via TPCI. and probably Crestron or some other interface like that. So you can use the TPCI commands. You can have like a pop star can press that button and it can make a special effect happen. It can release the hounds or whatever you want it to do. Lots of flexibility because it's programmable over TPCI. So I don't know, Peter, if this is another logical stopping point before I get into Quadversity for questions, or should I just dive right in?
I think we want to get into Quadversity.
Okay.
There was one question that somebody asked about the 8610. Do they have basically the same range as the transmitter if they put their 8610 in the booth up where the receiver is? Will it pick up the Zigbee just as well?
Yeah, that's a good question. Yeah, of course, the official question is it depends, but our access point has a high power mode. So it typically operates at, I think, 10 dBm, but it can be switched to operate at, like, I think 18 dBm, so almost 100 milliwatts. And that's in the US only. In Europe, you have to check with your regulator if that's allowed. I don't think it is. But in the US, it's measured by 2.4 is measured by duty cycle and not by power. So as long as we're under that duty cycle, we can transmit it really loud in the US. So whereas in Europe, I think they do actually have a power requirement too. So if you're in the US, you can turn your access point to high power mode, and gosh, yeah, you probably have as good range as you do with UHF, certainly good enough for skating.
I usually set it to manual frequency, and you use one of the two last frequencies in there, which do not overlap the Wi-Fi band. And
that's a good point.
Much better operation.
Yeah, so that's a good point. Zigbee is beneficial because it primarily works on Wi-Fi, but there are two channels that are just outside of the Wi-Fi range. So instead of putting your access point on automatic, you can put it on manual, as Peter does, and you can select one of those open channels. Of course, the access point can actually do a scan over Workbench. So do a scan before you put it on one of those open channels if you have time. But that's a good strategy, because generally, unless there's other Zigbee devices around, it's going to be clear and free from Wi-Fi.
Right. And Jason Glass wants to know, can the 82XFD also operate in single transmit mode without a transmitter putting out anything?
It can, yeah. It can operate in single mode, and in fact,
if you just don't put a frequency in, it'll be off.
Yeah. So you can operate it as a single transmitter, and in fact, we can do something with the PAs on the two channels called Coherent Combining, where we can use both PAs to increase the power in single channel mode. So in the 80X2 FD, you can operate it in high power mode of 50 milliwatts, which is the FCC limit now, if you're only using one channel. So if you're using the FD in two channel mode, it's limited to 20 milliwatts per carrier.
Okay.
But if you're using it in single channel mode, we can use those two PAs and we can actually give you 50 milliwatts. So
is that something you have to set, or you have to check with single transmitter mode, or?
Yeah. You basically take the transmitter out of FD mode, and then that high power setting would be available. If you're in FD mode, it just doesn't show up.
Go on to the elephant in the room, Quadversity.
All right. So this is where Dr. K is going to be a heavy contributor here. But I'll start a little bit and kick it over to you, Dr. K, next. Predictive diversity is essentially what we have in ULXD, and it's commonly known as blind switching, where the receiver has a single RF lineup and it's picking which antenna is best.
Right. So I don't know that well, it doesn't know what's on the antenna that it's going to go to. It has a pretty good idea of the antenna that it's on is going into a fade, and so chances are better if you switch to the other channel, and we do that before the problem really shows up. So it's kind of a proactive, hey, I can see that this is going south, and I'm going to predict that I'll be better off on the other antenna. So there was a time when during development when we would switch antennas And if the other antenna wasn't as good as where I was, I'd switch back, and I'd switch right into the dropout that I was trying to avoid. So we worked around that that issue. So it's pretty good at predicting which antenna is going to be better. But there's always a chance that both antennas are bad, and switching from one antenna to the other doesn't save you.
So the next slide that I have here is just describing how true diversity is done in the analog domain. Dr. K, can you describe that, and particularly how we did it on UHFR and Axient with Marcad? Did I lose you there?
I think
Yeah,
we
he
have.
definitely looks frozen.
All right. We lost Dr. K there, so hopefully he'll come back soon. But in the meantime, I'll do my best. So I think all of you guys know how true diversity works. In the analog domain, we have, in this case, we have two dedicated RF lineups, and we use them in tandem, and we use some form of combining in order to utilize signal out of each signal A, out of each lineup, RF lineup A and RF lineup B. So here in true diversity, we have an A and B for each channel, in this case, a 4-channel receiver. And we can use signal A and signal B or some combination of it in order to not utilize just one antenna, but truly utilize both antennas at the same time. And then there's the way that we do diversity on Axient Digital, which is basically, it's similar to in principle to what we do in the analog world, except instead of combining analog audio, we're actually combining digital data. So on the front of each one of these RF lineups would be an RF detector, and that RF detector is determining the quality of the data that it's receiving, and it's only passing the good audio and it's throwing out the bad audio. And then those digital signals, right, we're talking literally ones and zeros, are combined in the receiver after the decoder. And so we're summing them and combining them at that point in time. The big distinction between an analog system and a digital system is obviously you're not combining analog audio, you're actually combining digital data. Guys, let me know when we get Dr. K back, because I can't see.
Yeah. Sorry.
Looks like he's back.
I must be having some reliability issues of my own here.
So why don't you?
I've dropped out like four times.
You got to get
times in the last couple of minutes. Yeah, I need redundancy here.
So yeah, why don't you describe this, and we'll see how good of a job I did.
So there's a couple of ways to do diversity in a digital system. You can do it pre-detection and post-detection, which is like if you have a bit stream coming in, you can decide, oh, this is what all of these bits mean. But if you have multiple bit streams, I can kind of average the values of all of the the magnitude and phases of all the signals coming in, and use that to determine what the bit streams are. So, and we kind of do the best of both worlds, depending on how many receivers you have. But just like diversity in our analog systems, you can take the audio out of multiple radios and then sum them together and get a better audio signal. Or you can look at the link quality, the signal quality on each of the receivers and go, this one's the best. That's the one that you're going to hear.
Cool. So now this is an important distinction to make here. So before I move on to the next slide.
Let me ask one question before we get away from
please.
Sure. Is in this mode, is it using the RF from either A or B, or is it taking the best bits of both and putting them together?
Ah, well, that's kind of a secret.
Never mind.
But yeah, so that would be taking the best bits of both. It would be pre-detection diversity, but this in this scenario is post-detection. So you've already determined the channel, and now you're going to look at the quality of the channel and choose based on channel quality.
Right. So, okay, what I wanted to mention is before we move on to the Quadversity slide, notice here that, this is essentially a 4-channel receiver, just like I had that picture of the front panel before. This is just an RF depiction of that. And so what you can see is there's an A, B, just like the front panel for each channel. There are 8 dedicated RF lineups in a quad receiver. And right now we have A and B configured to channel 1 and so forth. So if you look at the back of the unit, right, you see that there's an A and a B. Each A and B coax input, or B and C, is connected to either an A or B here. So there's 8 of them in total on the receiver that connect to those 2 physical B and Cs on the back. This kind of describes a little bit what we were talking about earlier, where we kind of look at the signal of A and we look at the signal of B, and if there's an error, we can correct that error by looking at the same signal that we received on the other channel,
Right.
or on the other lineup.
So in this scenario, both receivers A and B have determined that it's a, the data is a 1 or a 0, or was something that they weren't sure of, and then they can look at, well, what did the other receiver get for that?
Right. So keeping in mind those 8 RF lineups that I talked about here, here's Quadversity, and just a reminder that we're talking about the quad receiver only. Here, we still have those 8 RF lineups that you saw, but now they're configured A, B, C, and D. And because we only have 8 RF lineups in total, that turns our 4-channel receiver into a 2-channel receiver. So when you're using Quadversity, that 4-channel receiver becomes a really awesome 2-channel receiver. And on the back panel, I can go back to that if this isn't too jarring for those of you folks. Just bear with me here. On this back panel, we have A and B, which are inputs, and C and D, which are outputs. This is for cascading to a second receiver. But when you put the box in Quadversity, A, B, and C and D all become inputs. So now back to my Quadversity slide now. That 4-channel receiver turns into a 2-channel receiver. And then you basically have, in principle, the same thing that Dr. K and I described for diversity, but now using double the amount of detectors, using double the amount of RF lineups. It's just more granular data collection, if you will, right? Because your transmitters are sending data over the air, and these receivers are essentially data collectors. Before they're audio devices, they're data collectors, and so the more data collection we can do with detectors and dedicated RF lineups, the better. Of course, whenever you add an extra 2 antennas, you get what, Dr. K? At least another 3 dB of link margin. Is that right?
Yeah, certainly you've got an additional redundancy for you to compare against. So the more receivers you have, the more you can be assured that at least one of them is getting the data that you want.
And so you might be thinking, well, number one, why do I need to use Quadversity if I want 4 antennas in like a distributed antenna system kind of environment? The truth is you don't. You can do passive combining of your antennas, but what comes along with passive combining is a fair amount of risk if you don't know what you're doing. And a lot of people on this call know what they're doing. You know, Peter, of course, Jason, who asked a question. These are people who do passive combining in a distributed antenna system for a living and do, frankly, a damn good job of it. But, you know, for those of us that aren't RF experts, you can get yourself into a lot of trouble with passive combining if you don't know what you're doing. You can actually create more fades and more multipath, and do yourself a disservice. Sometimes more antennas isn't necessarily better than fewer, better performing antennas.
So if you have, you know, two antennas and you sum them together, what you've really got now is one antenna. And you know, because I've taken two antennas and I've formed an array. And what I like to imagine is, you know, you've got your two antennas and I'm equally distant from both of them. So if I'm sending a signal and that signal arrives at both of those antennas at the same time, then, and I sum them together because the cable lengths are the same, then I'll have an increase of 3 dB in my signal. But what if one of those cables was 4 inches shorter than the other? And maybe one of those antennas was 4 inches closer to you than the other. Well, now at say 500 megahertz, those signals arrive at the receiver 180 degrees out of phase, and you get cancellation. So assuming that, you know, the signals at the antenna are of the same strength. Luckily, you know, in rooms that are highly reflective and with diversity, you hope that the other set of antennas doesn't have the same issue. And with reflections, you can, even if your main signal path is 180 degrees out of phase, a reflected signal may save you. But with Quadversity, all 4 of the antennas are going to 4 different receivers, so they're not summed together. And that independence means now I have, instead of really having 2 antenna arrays or one antenna, or, you know, 2 antennas that are summed together to form an array, I really now have 4 independent antennas, 4 independent radios. Each one can determine what the signal path is, give me a link quality, and then the receiver can automatically decide this is what the most likely data to come out of the receiver is. This is the most, you know, this is the highest quality audio that I'm going to get.
So you can use Quadversity for distributed antenna systems, and I drew a diagram here that demonstrates how that might be possible, but I'll talk through some other ways too. So on the back of your receiver, as I showed you, there are four inputs. There's an A, B, C, and a D. Those are being depicted as yellow, blue, red, and purple, respectively. And you can see that all of my yellow and blues go to one 2-channel distro, which in the case of Shure is a UA845, and that becomes my A and B distro. And then I take all of my C's and D's, all of those red and purple lines, go to my second distro, 2-channel distro, 2-channel input distro, which is a UA845, also handling my C's and D's. You can also use an AXT630 or another antenna distro as well. I'll note Professional Wireless makes a Quadversity distro. We don't, but they do. So if you want to get 4 channels in one RU, that's always an option for you. Wizicom, of course, makes all sorts of really cool antenna distro stuff. They have a distro that can do basically do Quadversity and a lot more, in fact. So there are options outside of Shure distros if you want to use Quadversity in a distributed antenna system. But this is philosophically how it would work. Of course, with a 4-channel distro, you would just have one yellow dotted bubble there, right? And 4 antennas connected to it that way. But this is how you would essentially wire up Quadversity in a distributed antenna system. And of course, for those of you that are familiar with, which many of you are, in speccing and developing DAS, you could just imagine you can multiply the number of receivers, multiply the number of distros and antennas, and then you can start adding some of those other third-party products I mentioned if you want to do things like zoning and zone control. So lots of flexibility with Quadversity and the things you can do with it. Some other things is placing them in a single zone. So I have these A, B, C, and D depicted here by color, and there's just a really rudimentary drawing of a stage. You can place, you can place 4 antennas on the stage, and you can use this to reduce the effects of body blocking. So if you have money talent, you know, on a handheld or on a body pack, she's going to be twirling around, walking up and down the stage, and just having 4 antennas kitty corner are just going to decrease the idea of there being any lack of direct line of sight the entire time. And it also increases your receive side sensitivity as well. If you're using HD mode, Quadversity is great because you can make up for that lack of transmit power at only 2 milliwatts by amping up your receive side sensitivity with extra sets of antennas. It's also real helpful if you're combating a noise contributor like an LED wall, for example. So, you know, LED walls have been getting better, but those of us out in the world are all familiar with bad LED walls and how they might contribute to the noise figure of a system. But this has been employed, this particular setup has been employed a couple of different ways quite successfully. My buddy JD Ducray, who I think's on the call, who's with Reba, has a Quadversity setup for when he works in the Coliseum at Caesars in Vegas, and he has a Quadversity setup where on the stage there's basically an A, B, C, D, and they have principals in frequency diversity mode and some that aren't. He has instrumentalists that are only on 2 milliwatts. He has some that are on high power. So Quadversity gives you just that added performance. And in their case, they're not using it because of a bad LED wall. They're using it because if you know anything about Vegas, especially post 600 megahertz, the RF spectrum is pretty lousy. And in a big venue like Caesars, there's just a lot of wireless and very little spectrum. So operating things at lower power, amping your receive side sensitivity via extra antennas, a really good way to deal with noise contributors, whatever they might be.
You're a good neighbor to everybody else on this strip who wants to use wireless.
Well, you have to be, right? You don't want them knocking on your door. And so here's another example. This is sort of using zoning. So you can create a distributed antenna system just by using an Axient Digital receiver. So I can put antennas A and B on an A stage. I can put antennas C and D on a catwalk or on a B stage, or in a green room, back in makeup, or in a quick change if it's a theater app or studio broadcast application. And no need for a distro. If you're just using 2 channels, it's as simple as that. Of course, if you're using multiple channels in multiple zones, as most of us are familiar with operating in, it gets a little complicated per my previous distributed antenna system diagram. But you can use Quadversity in principle for either a single zone application or for a 2-zone application. And I just wanted to show each.
Every year, Josh Flower and I do the Macy's Parade, which is on 34th Street between 6th and 7th Avenue. 6th and 8th Avenue, 7th and 8th Avenue. And the main stage is right in the middle of the block, which has a host platform and a performance area. You put A and B on the host platform, C and D, which is only about 75 feet away, on the main performance area. But then we also split A and B and send them via the WYSICOM fiber around the corner to where the truck is to pick up mics coming on floats down 6th Avenue, so they can prep and be pre-fade listened to before they get around the corner. And using the WYSICOM antenna selector, you can turn on and off any of those feeds. You use that also as the 4x4 DA. One question that Jeff Jones asked is, when you're not in Quadversity, what are the C and D, B, and Cs? Well, they're feed throughs for A and B. And it does
Right.
say that on the back there. Do the four in quad mode, do all the antennas have a bias voltage? Can they?
They do, yeah. So, oops, I jumped ahead there. It's 300 milliamp total. And so we just recommend 75 per leg when you're in Quadversity mode.
Right.
But it's theoretically 300 total spread between the four.
And what is that? What is your current model powered antenna draw?
Gosh, do you know what the power
That's
draw is
about
on an 874?
75 milliamps.
Yeah, which I would never use on 34th Street because we're right underneath the Empire State Building. But
Oh yeah.
there we just use all passive stuff. So there were a couple other questions, but let's continue with the Quadversity for now. In frequency diversity. Oh, I had a question. When you're in Quadversity mode, does the error correction work among all four antennas the way you showed it working among the two antennas?
Yeah,
Yes.
it does. Yeah.
So you basically have 4 times the amount of reception of getting some signal good.
Twice
Better
the
error
amount,
correction.
yeah.
Okay.
2 versus 4. Yeah.
So then you can actually get more range. I mean, if we had on Broadway, if we'd had all 4 antennas on the Marquee Theater, we probably could have gone to New Jersey.
I like to think of it as a higher probability of receiving the signal than extending the range. It's like,
well, that's true. That's true. Yep, definitely.
So let's get into frequency diversity, shall we? So frequency diversity is something that Shure has been doing for quite some time. And there are 2 different types of frequency diversity that I wanted to share. One of them is called frequency diversity switching. And this is primarily using 2 body packs. Here I'm using our micro body packs connected to a Y cable. And Shure makes a Y cable that goes, LEMO to, or 2 LEMOs to LEMO, or 2 TA4s to TA4. I know a lot of other companies do too. So you would use that single mic and a Y cable connected to 2 body packs, and each body pack operates on a different frequency. And you have channel 1 receiving the audio from, or the RF and audio from 500 megahertz, and channel 2 receiving the audio and RF from 550 megahertz. And we're basically utilizing both channels to ensure that if one signal gets stepped on, the other one can be utilized with no dropout heard whatsoever. So theoretically, if you're operating frequency diversity properly, and we've designed it properly, of course, you should not be hearing any dropout. So for example, in this scenario, if somebody suddenly were to drop a comm or some sort of destructive interfere right on 500 megahertz, you'd get an alert on the front panel that would say, whoa, like, interference on F1 using F2, but you wouldn't actually hear it in the audio. You shouldn't anyways. You should just be hearing seamless audio passing. A modified version of this, and you see this sometimes in theater, would be a double miking application where, and I don't know how often they're actually using frequency diversity in theater, but there is an application where you can use a double mic, double pack, which would be 2 body packs and then 2 microphones, 1 microphone connected to each body pack. And we even have a calibration mode in the receiver where you can calibrate the relative level of each one so that they're balanced. So that's frequency diversity switching. Frequency diversity combining, of course, is only available in the ADX2 FD because it's the only product that Shure makes, or really anyone makes, that has 2 dedicated RF radios in one form factor. And so FDC works similar in some ways because you're getting 500 megahertz and 550 megahertz. In this example, there's two channels on the receiver that each are getting dedicated frequencies, but they're doing this combining and combining the signal so that we're not, if F1 gets totally stepped on, F2 takes over. But if F1 is just degraded and F2 is degraded, we potentially could combine the remaining signal of F1 and F2 to create a complete picture. So that's how combining works fundamentally. And that's how it's distinguished between switching, because in switching, it's right, you have this little switcher here, it's either one or the other. But in combining mode, it's actually both. We're getting 2 bit streams, and they're being combined and utilized as best as possible. Of course, when you're using frequency diversity mode, you're using 2 channels of the receiver, right? So one frequency diversity handheld takes up 2 channels on your receiver. If that makes sense. So if I was using 2 frequency diversity handhelds, that would show up on channel 1 and channel 3, because channel 2 is being used to help channel 1 and channel 4 is being used to help channel 3, if that makes sense to everyone.
In frequency diversity mode, are 1 and 2 putting out the same audio and 3 and 4 putting out the same audio on the receiver?
Yes.
Yes, on the output side, yeah, the audio output side, yes. So
Right.
copy. Okay, so I wanted to share with you frequency diversity out in the wild, and this is funny because a couple of people that are responsible for this stuff might actually be on the call right now. I won't call you out by name just because I didn't get your permission, but these are really awesome examples of frequency diversity being used, as I say, out in the wild. So there's Booger McFarland. If you watch the NFL, you probably know he's commentating for Monday Night Football on ESPN. Here's a picture of him on the sidelines wearing 2 ADX1s. He has a special talk switch. It's not one that Shure makes, it's one that's been customized for him. And you've got this Electro IFB there. And this is a very common application for sideline reporting or for NFL referees to be wearing 2 body packs at the same time. It's definitely common in the broadcast world where the expense of having an extra channel from a coordination standpoint and from a hardware standpoint outweighs the downside of losing RF. I've got to say, you know, that I remember like growing up, the referee dropping out was a common thing. It was just like a common thing. And now that doesn't happen anymore. And I'm not saying that's because of Shure. I'm saying that's because of the folks that are doing cool things like this out in the wild. So referees don't drop out very much, thankfully, anymore. And that's because we're doing more intelligent things with the RF spectrum. And this is just one of many examples of how you can deliver reliable broadcast audio. So here is a screenshot. You know, I take a lot of pictures of butts, not because I like butts, but because that's where my body packs are. And so here's a picture of the NFL official Bill Vinovich, who did Super Bowl LIV, and you can see there he's got 2 ADX1s and a talk switch. You can't see the talk switch; it's on the front of his body. But I was excited enough to where I actually paused the TV and took a picture of it. But that's just another example of frequency diversity switching being used in a real world environment, right? He's got 1 mic Y-cabled to 2 body packs. God forbid if one frequency drops out, the other one picks it up without an issue, and our referee can still be heard when he's making those critical calls on TV. Here's another one. Thankfully, not pictures of men's butts. Here, these are pictures of Demi Lovato and Jennifer Lopez using Axient Digital frequency diversity at the most recent Super Bowl. So Demi Lovato used an ADX2. You know, this is an important application, right? I mean, we definitely don't want dropouts during the anthem of the most televised and watched sporting event in the world. So frequency diversity handheld was used in that application. J-Lo and her daughter Emmy actually used 3 different customized ADX2 FDs, and so there are pictures of 2 of the 3. You can see the black one in her hand in the little 4 picture, but we did a black, like a diamond, a gold, which she's holding, the daughter's holding, and we also did a red and blue, which I guess because of the costume and design situation they didn't use. But the idea is that we supplied these microphones for this event, and they worked out really well. And there was a Shure press release announcing all of this information, but I just wanted to share with you guys in the real world how frequency diversity is used and how it pulls off some of the biggest events, televised and otherwise. So maybe we can set up for questions.
Yeah, on frequency diversity, Kevin Parrish wants to know, can he do frequency diversity using X55 and G57 at the same time?
No, unfortunately, because the frequency diversity decisions are being made by the receiver, it would have to be made by the same receiver.
And the whole receiver has to be switched to that band. It can't just be half of it.
Right. Yeah. So
the transmitter can't jump out of its band.
Right.
Exactly. Yeah. On both counts. Right. They're limited to the hardware.
Jeff Jones wanted to ask, he's got 4 quad RX and 2 antenna UA844 combiners. Can all the antennas be active antennas, or do they have to be passive? I would say don't use active antennas unless you absolutely have to. I don't know his situation.
You can have all 4 antennas be active. That's not a problem. I would just make sure that you're using them to overcome some cable loss, or
Yes.
and that you have the gain set up on the active antennas appropriately for the cable that you're trying to use.
Right. It's not, again, the technology is there. Just be careful how you use it. John Christie says the ADX2FD is not legal for resale in Canada. Is that true?
Correct. Yeah, unfortunately, our partners up in Canada, Industry Canada, did not completely follow the FCC's distinction of how to operate a frequency diversity transmitter versus a non-frequency diversity transmitter. So sorry to my Canadian friends like John.
Right.
We're still working on it. All is not lost.
What exactly does the auto tuning antenna on the micro body pack accomplish?
I'll start on that, but I'm sure Dr. K can go a little deeper. So there are really 4 antennas on the body pack. There's a UHF antenna, obviously, which is transmitting UHF. There are 2 ShowLink antennas, which are actually sending and receiving that Zigbee information. But there's also a power sensing antenna on the transmitter as well. And so maybe, Dr. K, if you can talk a little bit about how those 2 antennas, the UHF and the power sense antenna, work together.
Sure. So anytime you make an antenna small, which we had to do in order to fit it in this micro body pack, you narrow the bandwidth of the antenna. And so this particular antenna, it knows what frequency you're tuned to, and so it can tune itself for that frequency. But because it's narrow band, when you put your hands on it or put it on your body, it detunes the antenna. And so there's a sensing antenna that senses that the power has dropped, and it retunes the antenna to make up for the fact that you've put it on your body.
So it's sensing its own transmitter antenna.
It's sensing its own transmitter antenna and says, the power has shifted, so my transmitter antenna must be being detuned, and then it's got a tuning loop that corrects for that.
Yeah, yeah. Very clever. Dan Newburn asks, if you're using a Y cable with 2 AD1s or AD1Ms, is there a reason that FD-C can't work?
Yeah, so FDC is really only meant for a frequency diversity handheld. So when you're setting the receiver up, if you set your receiver to FDC, there's actually an alert on the screen that says, hey, this is intended for an ADX2 FD only. And there's a really good technical reason behind it. It's because you have two different digital radios that aren't in synchronicity with each other. Isn't that right, Dr. K?
Right. So it would be difficult to make sure that the bit streams coming out of the two transmitters were synchronized with each other.
I was on a show with Katy Perry, and she had about a dozen, literally a dozen different, actually the same mics, and they all looked differently because they were color coordinated to her costume. And this is another color coordination question. On the JLO microphones, are those jewels just adhered to the normal mics, or the case is a different case they use?
It's a really good question. So the jewels were just adhered on top of the existing bodies, but just, I don't want to talk specifically about her mics, but just generally on customization, it's done a couple of different ways. One way it's done is by putting applique just on the finished product. So you would get like a black one microphone, and then you just put white diamonds on it, for example. And so in your example, that's what happened there with one of those mics. But you can also have the microphones painted a different color, and Shure has instructions that we can offer our customers on how to do that properly, because we have had some instances of people taking our transmitter apart, painting them, putting them back together, and then having less than ideal performance. And that's because there are very specific things you have to do with respect to masking. So we have a document, a video actually, that we put together last year that demonstrates how to safely disassemble and reassemble a unit while making sure that as it's being customized, it's being properly masked off.
Now, I know on the Katy Perry show, they were not Shure mics, but the monitor engineer was able to switch the insides of the mic in about 2 minutes because he'd done it so many times. Do people typically do that with the Shure mics as well, if they've got a blinged body and they want to just change the transmitter back and forth without having a big issue with that? Or,
I mean, we wouldn't recommend it. We wouldn't recommend disassembling a transmitter and putting it back together without bench testing it first. And of course, you could do that yourself, but I wouldn't. You know, if I were an RF coordinator or somebody responsible with the production, I wouldn't let that happen. And in fact, there are sleeves that kind of accommodate that. So in my experience, you can just get a sleeve that has, in fact, JD, again, my friend JD with Reba, he has a sleeve that they put over the mic that's like a red sequin, because she wears a red sequin dress during one number that she does. She sings like an emotional kind of ballad, and she wears this really beautiful red sequin dress. And in between that change, they take her microphone and they put the red sleeve on it so that it looks like red, you know, but then they can take that sleeve off.
That's not an official Shure sleeve product.
No, it's custom. It's something custom, but you know, their wardrobe or whoever made it for them. It needs to match the dress, so usually it's something like the wardrobe does.
I thought they did it the other way. I thought they found a red mic and then made the dress to match it.
We wish.
Exactly. Mark wants to know, does frequency diversity allow the use of programmable button for, say, talkback?
Yeah, absolutely.
Or in other words, it's the same module goes on top of the unit for talkback, but would treat it the same way. In other words, when you're talking back, your main audio out is not active.
Right. Well, it's configurable, so you can make it so that the button routes to more places. You know, you can keep it so there's a matrix. It'll have each output. It'll say Dante AES XLR quarter inch, and then it's like on off. You know, depending on what you want that talk switch to do in its status. So if you can set it up that way, sure. But you can also set it up to where, hey, I press this button, and not only does it activate the XLRs, it also activates the AES.
And that button could send the audio out a different output on the receiver, like the quarter inch output as opposed to the, which I assume you would want. You want to talk back, yeah.
Right. So an example I like to use is sideline reporting, and I know that CP Communications does this a lot with a lot of other big RF providers do this as well, where they provide a talkback so that the sideline reporter can be speaking to production. And I don't. This is probably not a totally accurate example, but my impression of it is, you have Susie Colbert or Pam Oliver, one of these sideline reporters roaming the field, and she has a producer in her ear saying, "Oh, try to get a hold of Tom Brady. He's on the sideline right now, and he looks pissed off." And so she walks over and she tries to get a hold of Tom Brady, and then she goes, "Okay, he's going to be ready," and then they get the camera all set up, and then when she depresses that mic, or when she presses it, depending on what the how they have it configured, then now her audio is not only making it to the house, but it's also making it to the broadcast as well. So it's used basically for communication, for backline communication.
Gary Weiss wants to know, for predictive diversity, is there any kind of log generated to show if one receiver is not working as well as the other receiver, like maybe failing?
No, that's a great question.
Like maybe it's always going to one receiver all the time.
Yeah, so really the logging would be of value if you have a networkable wireless system, right? Because you want to be able to see the log.
Right. And you'd have to go back and look at those logs.
Yeah, so the only product that we really make that's switching or predictive diversity and networkable would be ULXD. So theoretically, I mean, we could have in the event log, because there is an event log in Workbench every time the antenna switched. But if you've used ULXD, I'll tell you, it switches a lot, like maybe 100 times a minute.
There would have to be some app to analyze that. Right.
Well, it would just fill your log with a bunch of data.
What I would recommend, though, is I do know some people will remove one of the antennas, and predictive diversity doesn't know that you did that. So when a fade starts to happen on the antenna that's selected, it will try to go over to the antenna that you removed. So
and be worse.
It does tend to make things worse. So predictive diversity assumes that both antennas are there.
Because it's not pre-checking before it goes over there.
Right.
If it's bad, it's going to move. Right.
Right.
It
actually moves before it gets bad. It tries to predict. That the channel is going away.
Basically, it gives up.
Right.
The buttons can be either momentary or push on, push off. Can be programmed for momentary or push on, push off.
No, it's just a momentary.
Okay.
The latching, I think, is what you mean, right? It's just it's not a latching switch; it's just momentary.
Hold on. Have you ever seen bling affect the RF performance?
Definitely, yeah. And that instance I just described, I don't know, maybe you can talk a little bit about that, Dr. K.
Well, I know somebody who sent their transmitter out to be chrome plated, and they chromed over the antenna.
So great.
So that little black rubber end cap, the antenna lives down there. So don't paint it. Don't paint it with metallic paint, and don't chrome it.
Got it. On the push to talk operation, can it switch between one Dante channel to another Dante channel?
No.
Don't want to use analog, or it only goes to analog?
It can either go to one of the two analog outs, either the 1/4 inch or the XLR, the AES out, or the assigned Dante out as prescribed in Dante controller. But we're not monkeying with Dante routes when we do the talk switch. So unfortunately,
your push to talk could go out Dante instead of your main feed, is what you're saying.
It could go out Dante, but it couldn't go out to a different Dante channel, right? Like if you're, let's say your your Axient Digital receiver channel 1 is connected to Dante controller, 4. You couldn't hit the talk switch and have it go from 4 to 5. It has to stay on 4. That's a change you'd have to make in Dante controller.
Does the fob operate as Zigbee, or?
Yes, it does. It operates on Zigbee, actually. So I wanted to be really clear when I made that distinction, especially with the ring talk switch, because the ring talk switch, number one, it just looks like it's not Zigbee because it's hard connected to the
But it is
handheld.
the same. Right.
It is, and also in our legacy Axient transmitter, it actually was not Zigbee. It actually used like modulated voltage from the capsule, the bias voltage from the capsule, and we chose to use Zigbee with our new version of the talk switch because of artifacts when pressing that button. Of course,
And
now
it's
the drawback. Sorry, go
It's
ahead.
actually communicating with the transmitter, not the receiver.
It's an incredibly short hop, right? It's like a centimeter or whatever
Right.
it ends up being.
And the transmitter is saying to the receiver, hey, I've got a different channel for you.
Right.
Right. Does predictive diversity have switching noise?
It shouldn't,
No.
but maybe Dr. K can talk about that.
So it's used in two different, it's used in both analog systems and digital systems,
Right.
but it's done differently in each. In the analog system, it's like fading from one antenna to the other. So it's not a hard switch, because if you hard switch in an FM system, that phase discontinuity between antennas is demodulated as a click.
Oh, okay.
And so you would hear an audible click every time it would switch. But in a digital system, there are parts of the transmission, like a preamble, where there's no audio information, and maybe you don't always have to decode the preamble. You can live without it occasionally. So the switches occur really fast, but they occur during the preamble, so that audibly there's no artifact from the switching.
Has anybody modified the fob to operate as a foot switch?
Not that I'm aware of, but it's possible.
It's a great idea.
Particularly where a
some
performer
stories
has
of
their
people
mic
Mm-hmm.
on a stand and they don't want to reach up to the mic. They just want to push a button and talk to their band.
Yeah, I guess that could be, it could be done. Of course, taking apart that thing, it does have an antenna and a radio inside of it, so you really need to know what you're doing. I know of at least one customer and colleague of mine that I mentioned earlier that modified some talk switches, but I really don't know what they did with it. So
Sounds like a product opportunity to me.
yeah.
John Christie points out that the momentary switch on the 651s in the receiver can simulate a latching situation. So in the receiver, it can act like a toggle. You're pushing it, but in the receiver, it goes here or there.
Yeah, that is correct.
When does your ENG quad receiver come out?
You're trying to get me fired. Yeah, this is something that I have to say a lot, but
oh, you mean you're actually going to make one? I was just kidding, but
yeah, what I have, yeah, we always are looking at new opportunities and competitive products that are out there, and if you have if you see a hole in Shure's product portfolio, we're probably fixing to fill it, but we can't talk about things that that are in development.
Do the fob and ring switch require show link, or do they operate directly with AD?
No, they require show link actually, and which means they require batteries, and which means they are only for operation with the ADX handhelds.
Right.
We actually have a service kit for the AD2. It's a little known fact that underneath that bezel, there's a button that can be programmed as a talk switch. So there's a little service kit that you can buy from Shure where you pop off the bezel, the standard bezel, and you put on a different bezel with a button. And you can contact our service or customer service department about it, but we can modify it for you, or you can just buy the parts from us, and you can essentially turn an 82 into a talk switch version that way.
But the talk switch on the handheld mic require a battery also?
Not on the 82, it doesn't, because there's a dedicated button. You just have to have access to it. But for the 80X series, because it uses Zigbee and because they're modular, they do.
Oh, okay. Asia says, in one of the webinars last week, one of the techs said about Axient Digital Quad mode with the push-to-talk button, the receivers have a mode that doubles their Dante output channels so that the push-to-talk can switch between outputting on channels 15, 26, 37, 48. It's a new feature. Does that really exist or not?
Yeah, I don't think that exists. If I'm understanding the question correctly, I'm not aware of our talk switch being able to route. It can route to Dante, but it can't select Dante 1, 2, 3, 4, etc.
Right.
And I would know.
Yeah, routing Dante is not instantaneous, so it would be useless anyway, because it takes a moment for Dante to resolve that change.
No, it wouldn't physically wouldn't be Dante, but it would be taking the audio and putting it on different outputs of the Dante system that already existed within the mic.
Right,
right.
I think you guys are talking about the same thing though, right? Yeah. Like if I were to go into Dante controller and move it from 1 to 2, you get that little hourglass and then it changes. That's the delay I think that Mac's talking about.
Yeah.
Can the fob also be used on the handheld instead of the ring?
It can, absolutely. Yeah, if you want to keep something in your pocket or on a lanyard.
Got it. Rajan wants to know, is there a digital SLX system coming?
I have to give you the same answer I gave about the 4-channel receiver, portable receiver.
Got it. Timo wants to know, will there ever be a plug-on transmitter with a measurement mode? So it's got a calibrated output.
That's a good question.
Like we used for the electrosonics version.
That's a good question. And hello to Timo in Finland.
Yeah.
Shout out to WaveTool. Not with Axient Digital, unfortunately. At least in the current modulation scheme that we use is not phase linear. Or not the modulation scheme, but the codec that we use is not phase linear.
Right.
And so it's not suitable for measurement applications. We could theoretically develop a measurement mode solely for obviously measurement. But to date, we have not done that.
I'm just looking back at the beginning, see if we missed any questions, because we're basically at our time limit now.
I can stick around if you.
One wish list thing from me. I often get an ADX with show link system from a rental house, and they've done it all on DHCP, and I want to set everything to be fixed, or vice versa. They've done everything on fixed IP, and I want to do it DHCP, but I then have to set up my computer to be in the 169.256 band, and then reset the show link to get it to be in there, and then connect to it, and then change it to what channel I wanted. And I wish there was a little manual control window on the show link to allow you to do that instead of going through all of that folder raw.
Oh, sure. Yeah. I mean, I guess that is a drawback, is that you have to instantiate a connection to the access point in order to change it. So you have to go through that workaround. Yeah. And you're totally right. If our access point had an LCD on it, then it would be programmable right there.
Yeah.
Yeah. It's got an IP reset button on it, but that wouldn't essentially.
That's what I use, right?
Yeah.
You reset it back to its default. Now, That would be another thing. Just print the default frequency on the bottom of the unit. I always have to go back to the manual to find it.
The default IP.
Well, actually, it defaults to DHCP, but doesn't it always default to the same actual IP?
I think the same substring, but not the
out by the server, wouldn't it?
Yeah.
Well, unless there is no server, it's just
Well, it has a fallback. It's like a 169.254 something, but it's not going to be the same one every time.
I think we pretty much answer. Oh, here's it's same on the reference mic. Instead of a plug-on transmitter, could you make a reference mic capsule that can go on the 82 body for measurement mode?
It's still the codec though. I mean, we could, the capsule would be one component, but it's how we carry the audio payload over the air, and we're doing that with a non-phase linear codec. So we would still need a different codec.
So it's a codec that's making it measurement quality, not the capsule per se.
Yeah, I mean, of course, you want to use a good flat capsule for measurement. So they're really two different things, right? You want a flat capsule as a good starting point, but then if the codec isn't phase linear, when you read it on Smart or whatever, it's just going to look wacky. You know, it assumes that these systems are linear time interval systems, and in the case of Axient Digital, and frankly, most digital wireless microphone systems are not using phase linear codecs.
Right. Christopher asks, on diversity, are output 1 and 2 mirrors of each other, the same as with 3 and 4?
Yes.
So you only need one audio. So you only need one audio output to the system because they're
copies. Yeah.
We're talking about AES, I think, right?
Well, we're talking about frequency diversity here, but
1 and 2 actually have outputs on them.
Yeah, right. So you can just be connected to one, you can be connected to 2 or both.
Right. Alejandro asks, the bit correction, does it have the same performance with different signal, the noise ratios? It's not a complete question, actually.
I'm not sure I totally understand that question, but the performance of the system in terms of, I guess I would need to know in terms of what when we're talking about. I mean, as this in an analog world, as the RF signal to noise degrades, so does the audio SNR. They're somewhat related. In a digital system, that's not necessarily the case.
Okay. And back when we were talking about antennas and DAs and passive splitting, are cable lengths the only significant in passive combined antenna arrays? Or does it apply? To me, the only time it's significant is if my 2 receive antennas are right here next to each other.
Right. I think Mark was making an illustration, not saying this is a rule. It's the path length of the signal through the air and through the cable.
Right. It's both. So the array that you form is dependent on the spacing between the elements, and the length of the cables that connect them to sum them. So, you know, you can have 2 things right next to each other with wildly different cable lengths and then get cancellation, or you can have things, farther apart.
Right.
And
the only time I've seen people take care in that is if they're building an array of several antennas to get a particular pattern, and they do exactly the same length cables to a local passive combiner rather than running them hundreds of feet out.
So my point really was that, you know, if you're just summing antennas, you kind of have to be careful how you do it. But I know a lot of people will have one antenna in one room, another antenna in another room, and they're summed together, and they'll probably put an attenuator in one of the paths so that, hey, I'm not really getting that signal from that antenna when I'm not in that room. And that's a very valid thing to do. And then I don't worry about the array that I've created. Or if they're directional antennas, I might take the other antenna and point it in a different direction. So I'm not getting the signal, at least nearly as strongly from that antenna until I get in front of it, until I get in the direction of the antenna.
Did a show where I was using a helical for the main stage, and right behind it, I was using a paddle to cover just a little part of the stage that went behind the antenna. And I put a little pad and a little combiner right there. So it was basically a helical with a paddle right behind it, but the paddle was in it 6 dB less.
Right. I've had more trouble with people using 2 antennas in a transmit application.
Oh,
where they're
never,
taking
never do that. Never.
Yeah, that is that's a much trickier situation.
Yeah. Back early on in the show, I talked from Lucas. He was talking about having WWB control multiple receivers, and he explained his question a little bit better. What he wanted was he wanted to be able to have a spectrum manager change the frequencies of 2 different receivers to the same one because they're in different areas.
Yeah, I thought that that I understood that question, and that's something that we're not currently supporting, is the idea of receiver linking is what he's talking about.
Right.
So it's currently not a feature as part of our capabilities, but it has been requested quite a bit.
Any new questions down the bottom here?
Yeah, actually, Alan Hennigs asked a couple of times about the push-to-talk switch. Can it light up to show that it's activated?
The fob has a little light on it, but we did not put a light on the ring because you can see the status of it through the, you can see the status of it through the LCD of the handheld. The handheld LCD becomes like an extension for the talk switch. It'll tell you the battery life, whether it's activated or not.
And A. Michael says, gotta hate the reliance on the link local standard as an actual usable technology. Why?
I don't know. I do like local link.
Works for me. And lastly, Gary Weiss wants to know, what's the optimum distance between 2 antennas not in an array? I say 1 wavelength or
Quarter
greater.
wavelength, right?
Yeah.
Whole wavelength or later, I say.
Right. The idea would be that you don't want the antennas to be seeing the same field. So the farther apart you can get them, the better. But I did some experiments to show that if you take 2 sine waves and you put them 180 degrees out of phase, you sum them together, of course you don't get any output. But if you move them just 10 degrees apart, now you're only down like 15 dB, right? If I take 2 sine waves and I just move them,
move the sine waves,
just move them by 10 degrees, you get a lot of your signal back. And so that's kind of the idea behind using 2 antennas on a personal stereo monitor. People will, might say, well, they're very close to each other on that pack. Well, sure, I'd like to get them farther apart, but you don't want the pack to be huge. But just 10 degrees of RF phase separation between the antennas can recover most of your signal. So farther apart is better, is I would say more optimum, but as long as you get them, I'd say a 1/6 of a wavelength or more, you'll be doing okay.
Okay, so
RF social distancing.
Exactly.
That's
145 megahertz distance between people, exactly. How long do the batteries in those buttons last, and how do I know when it's going dead?
They last a fairly long time, it all depends on how often you're pushing it, of course. But I will admit, in the instance of the ring, it's not obvious when the battery is dead. You actually have to put it on a transmitter and press the button, and then it'll give you a low indicator light as you're pressing the button. So you know, we didn't put an LED on it mostly for power draw. We wanted it to draw as little power as possible. But you know, if you're an A2 setting it up, you're probably just going to put a new battery in it. You're not going to have an easy way to fire it up and see what the battery status is unless you actually connect it to a transmitter.
But if somebody's only using it a half dozen times during a show, you don't have to change it every show.
No, I mean, yeah, it depends on a couple things too. It's a little more predictable with the fob because it uses a AAA battery, and profiling. Yeah, well, profiling them is pretty easy. We know what an alkaline and a nickel metal hydride and a lithium are all going to do. But in the case of the ring, it uses a coin cell, and some of the coin cells, like air cells, have very different roll-offs than a gosh, I forget the two profiles. There's like a zinc, and then there's another one. I can't remember the name of them, but one of them, the air cell version, is not designed to be used outdoors in cold temperature. So, you know, if you're sidelight reporting in the winter and you're using an air cell coin battery, it's going to roll off a lot quicker. So
and you see a lot of reporters holding their mic under their arm.
Yeah, with big gloves on.
Exactly. Will you talk a little bit more about RF interference detection and avoidance?
Sure. So the backbone of all of the interference and detection and interference features, aside from the access point itself, are the brains of the operation, or the AXT600. The AXT600 will manage backup frequencies and can automatically deploy them. There's 8 analog RF radios in here that are constantly assessing different parts of the spectrum that this box operates in, and then using the results of that to provide scan information and also to manage the backup list. I'll talk more about the backup list in a second, but the backup list could be derived in 2 ways. Of course, it can be derived via Workbench. If you have a spectrum manager in your network with a bunch of wireless gear, it'll deploy frequencies to your rack, and it can deploy a pre-selected amount of backup frequencies into what we call the CFL, or the Coordinated Frequency List. But if you don't use Workbench for coordination, if you're like some of us, not me, of course, but Peter likes to use IAS. You can use IAS, you can export the frequencies out of IAS, and then you can import them into the Spectrum Manager. So the Spectrum Manager can manage your backups or Workbench's backups or anybody's backups. You can walk into a venue and, you know, an RF engineer of the venue can say, here are your 20 frequencies, and you could just plug those all in manually to the frequency server if you wanted to. So lots of flexibility with respect to the AXT600. It also can demodulate analog signals. So this is really helpful. I mean, a lot of spec ANs can do it too, but if you don't have an RF analyzer and you want to find out what that thing is on, you know, 490, 500, you can tune the Spectrum Manager to that frequency, and you plug a headphone into the headphone jack, and you can, if it's analog, you can demod it and hear exactly what it is. So you can catch a lot of, you know, E&G folks popping up with their analog products. You can demod it, you can listen to who they are, and you can politely ask them to step into the RF coordination area to get a new frequency.
Sometimes just listening to what's on that channel, you can determine what it is. So
yes, you know, yeah, true.
Even if it's digital signal, that sound might clue you in as to what's bothering you.
Yeah, and in the way it looks on Spectrum too, right? If it's modulating, it's probably analog. If it's constant power, it's probably digital. That kind of thing.
On the bottom of the show link, there's a little antenna that looks like the antenna on the bottom of a handheld mic. What is that used for? Is that?
Oh, that's the scanning radio. That's what does the scan.
Okay. Yeah. So this is. Would you recommend that the 600 be put on the normal antenna DA, or have its own antenna?
I'm sorry, you're talking about which?
The AXT 600, would you recommend its antenna to be put on the normal system antenna you've got using, or on its own antennas to scan by them?
Oh, I think it should be on one of the legs of the distro. So you want it to see the same signal your receivers are seeing. I think a common, if I'm understanding your question correctly, a
correct.
common, if like misconfiguration, if you will, and it's really not a misconfiguration, but just not ideal, is you take your antennas that go into the AXT 600 and then you go out of the 600 into a distro. Not the ideal way, because that's a passive split. You're losing 3 dB right there, and you're not passing the same signal that those antennas are seeing onto the receiver. Whereas if you just put the 600 as one of the connections to the distro, that spectrum manager is seeing literally the same spectrum that all your receivers are seeing, and will be making the most accurate decisions.
So none of the frequency changing abilities with the show link is possible without the AXT 600, right?
Correct. Yeah. So
you can't just put a show link on your system and take your workbench and change the frequency. You've got to have an AXT 600.
You can change the frequency manually, right?
Okay.
Like
with show link.
Through Workbench.
Workbench, I can change the
Workbench.
Yeah, I can go into Workbench, change the frequency of the receiver, and it'll automatically send it to the receiver. If I want to send
an AXT 600.
Sure. Oh yeah.
Right.
Okay.
Yeah.
Okay. So I don't need
the show link will do will tell the transmitter where to go.
Exactly. I only need show link if I actually want to tell the transmitter to jump. But
have a backup list of frequencies, right?
Totally. Like a common list, I know a lot of the Claire folks that are, the touring folks on Claire request AXT 600s for like their PSM 1000 rig. It's not going to automatically shoot frequencies, but they just use it for management, and they'll use it in manual mode. So they'll have, okay, these are my 4 IEM frequencies, and then I have 20 backups, and then I use the spectrum manager to tell me how my backups are doing, so that if my artist complains about their frequency, I can just shoot them one of my backups manually.
So the 600 will send frequencies to a PSM 1000 transmitter.
No, you'd be.
I mean the transmitter, it is powering their ears.
No,
that's got to be a manual operation.
It's a manual switch, yeah. So
then it's only using it for monitoring it.
Right, exactly. And they're doing that deploying by themselves, because remember, you can see, and actually I think I have it in the next slide here, or no, I'll go a little forward just to make this point here. This is how your frequency list looks in AXT 600. So you can monitor all the frequencies right from Workbench. And if you have show link, you can deploy them, but you don't have to monitor them through that little display on the front panel. You can monitor them in a really robust way in Workbench. It'll give you some pretty granular information about each frequency.
Yep.
Go back to my slide now. Okay. So the next thing that I wanted to share is just how interference detection and avoidance works a little bit. In the Workbench world, you have coordinated frequencies that are sent to the receivers, either through a coordinating device. It could be Workbench or a spectrum manager. And then that pool of coordinated backup frequencies sits on the AXT hardware, 600 hardware, and that's what I call the CFL. That's what it's called. And again, that stands for Coordinated Frequency List. And so we have these frequencies on the receiver, right? These cylinder rows are each meant to represent a 4-channel receiver. So we could say this is channel receiver 1, the second row is receiver 2, the third is receiver 3. And then we have backup frequencies, right, that are just individual backups just waiting to be deployed on the spectrum manager. So here we're seeing that on the third receiver, channel 1's frequency was reported as bad. The receiver says he has interference. And then just voila, we take one of the backup frequencies and we deploy it to channel 1. We take that good frequency that became bad and we then manage it in Workbench. We call it bad, we put it at the bottom of the list, and then we monitor it for good behavior. If it over a period of time, if it's clean for long enough, it'll get ranked back up the list. And so here's a slide I was showing just a second ago. I mentioned that you don't have to use Wireless Workbench if you're using a spectrum manager. Basically, any tool, coordination tool that's possible of providing a CSV export can do this. So using Professional Wireless's IAS as an example, I know they have a export to CSV function. You export that. You do have to clean the list up a little bit in Excel. And then you could import that list into the Spectrum Manager, and they're there. There's a video that a former Shure associate named Sam Drazen, who was working on Wireless Workbench, did, demonstrating how to take third-party coordinations and put them into Workbench. So if that's something you're interested in doing, that information is available on YouTube, and you can definitely check it out. But
How do
that
you spell his
circle,
last name? D-R-A-Z-E-N?
Drazin, but you're not going to find it on YouTube by searching his name. If you just basically search Wireless Workbench IAS import, it'll pop up. His name's not important, unfortunately, because he no longer works at Shure. Great guy, but just no longer works at Shure. So
He thinks his name is important, but
yeah,
There we go.
I do too, but just not in the context of finding this YouTube video. You'll never find it if you type his name.
That is really interesting to me, and I'm going to go look at that right away.
Cool. I'll make a note. I'll send that link to you, and then if you want to share it with others, by all means.
Cool, because there's always been an issue, and everybody's thought, how can I take my IAS stuff and just import it right into Wireless Workbench? And I say, I don't think you can.
Yeah, well, not just IAS. I mean, Spike, Win Radio, as long as the coordinating device can export a CSV, we can take a CSV. Now you have to massage the CSV a little bit so that it looks right.
CSV with no extra junk in it, right?
Yeah, exactly. And that's what that video tells you mostly, is how to, because doing the export out of IAS, for example, is fairly easy. And doing the import into AXT600 is fairly easy. It's really knowing how to massage the CSV file right is the trick there.
Sure.
Hence the importance of seeing that video. Cool. So here's essentially how that process works. It's going to take me like 1,000 times longer to describe it than what actually happens. This all happens in as quick as 30 to 50 milliseconds. So our receiver is operating fine, and suddenly it detects interference. When it sees interference, if it's set up for interference avoidance, it'll request a new frequency from the AXT600. The AXT600 will pick that frequency, and then it'll push that receiver to, push that frequency to the receiver over Ethernet. And it also pushes that frequency over Ethernet to the access point. The access point, wherever it is out in the field, sends that notification to the transmitter. That seems like a long, arduous process with a fair amount of risk, but I'll tell you, it's extremely reliable, and it happens certainly under 100 milliseconds, generally within 30 to 50 milliseconds. So not only is it fast, but sometimes it's inaudible. If you catch it in between the words of someone speaking, or for a time when they're not singing, their frequency can change and the artist is none the wiser. And so, there are times when the machine, definitely shouldn't be trusted, and you want to do a QC check on every frequency that goes out. But on the flip side, we have customers, mostly in the pro touring world, where they show up to a venue, they turn on the system, they don't even do a coordination. The frequency, everything jumps to the frequency they were on the night before. They have a good backup list, and the backup list will normally sort it out before the show even starts. So the backup list will deploy frequencies if the coordination isn't good that it last used. And you'll talk to artists or to engineers, and you'll say, oh, you use ShowLink automatic avoidance? And they'll say, yeah. And you'll say, how many times does it switch on you in a given show? And they'll say, I don't know. Like, they don't even look at it. So obviously for some of us more advanced RF experts, we definitely are going to want to make those decisions ourselves. But if you're a monitor engineer and you're tasked with mixing a show, and you're not afforded the great value and benefit of an RF engineer, then you've got to do it on your own. And they want to mix, they want to make sure they're keeping their eyes on the talent, and great opportunity to let automatic interference.
I typically change
with
it much
things.
more than the XT600 would want to. I'll be watching my primary frequency. If I see a little bump of something show up within 100 kilohertz, a little thing, I'll just switch frequency like that, and nobody ever notices.
Right, and yeah, and that's something that we our box can't do. Right, is make subjective determinations. So, and that's why you guys do what you do, and why we have these different modes in the box. Like we did, we would have been really foolish to like make automatic mode the only mode, and we realized that not everybody operates in that environment, in that workflow. So you would use just the prompt mode in that setting.
In the automatic mode.
Well, I mean, I remember back when Axient Analog, that, when I first saw that and I saw, oh, automatic. Well, no, I know best. This needs to be a manual. When it comes time to change a frequency, I will be the one determining when that new frequency goes. This box wouldn't possibly know what is important to me. And it didn't take very long before I flipped it over to automatic. The box is far better at determining than I am. And I would tell you, my experience has generally been that it will see noise before I hear anything. And that's one of the things that I trust in that system. But if it's a show Pete and I would be doing together, or somebody else that was a frequency coordinator, I'm counting on them to give me what those frequencies are that are going to the CFL. But I'm going to then, benefit from the auto mode. I don't care if it changes frequencies constantly, right? Because if it does, something is interfering with me. Now, I will tell you, years, when we first got into it, I was on a show with a friend of ours, and when we lit everything up and all the thirds, everything from the intermods, I should say, just kind of kicked on, and the machine's kind of just throwing out frequencies, because we had created like this perfect storm. I didn't lose anything. It was great. I was like, this is awesome. He's like, tell it to quit using up all the frequencies, because we look at frequencies like it's this finite, oh my goodness, once I use up all my good frequencies, you use a frequency once, it's no longer good, right? And that's where I think, I would challenge people to stretch and let that system watch for you. I actually found greater confidence when I started doing that, when I started saying, okay, I'm going to go into auto if I'm doing frequency diversity. And even cases where I was short some channels to do double packing, I made decisions to go single because I knew I could pitch a frequency. And 9 times out of 10, even if it automatically did it with a single frequency, the chances of you hearing it, were remote. But if you really, really had to be concerned about that, and you couldn't have 2 packs or a frequency diversity handheld, waiting for that breath, click the button. I mean, it literally was just that fast. I mean, I never was able to trip the system up. So I don't want this to sound like an ad, but that's part of what we're thinking as whether we're mixers or whether we're, managing the RF system. Let the machines do the work. That's what they're there for. Focus on what you need to be focusing on and anticipating. So sorry, I interrupted you, MJ. Go right ahead wherever you were.
What kind of knack is going on between the show link and the receiver and the transmitter to make sure everybody's got the right frequency before it shifts it?
Well, it's only sending out one frequency at a time, right? It's not sending out, oops, sorry. Go back to that slide. It's not doing it all at once, but all those backups are pre-coordinated, right? So all those backups work with each other. So you can send out all those backups at the same time, and they should all be pre-coordinated. So provided that you put in your CFL coordinated frequencies, and Workbench will tell you that too. If you import it into CFL and you do a calculation, it'll let you keep them, but it'll tell you this list is incompatible.
But what an attendee is asking is, how do I know that the system is going to get the right frequency and time in the receiver so the transmitter can be changed and they all happen at the same time?
So,
It's just because it happens so fast. Go ahead,
well,
Dr.
the
Michael.
receiver, the receiver says, well, I need a new frequency, and the frequency manager goes, okay, good, I have one for you. Here it is. And it's going to tell the transmitter, here's the backup frequency as well. So now both the receiver and the transmitter know where to go. They didn't go there yet.
Right.
What it'll do is it'll say, I want you to
Ready,
go
set, go.
in 3, 2, 1, and then they go.
Got it.
Right,
They have a
right,
state
right.
manager. Got
So
it.
the first thing you got to do is tell both parties where do you want them to go, and then you count down when you're going to get there.
Cool.
Okay, so let's get
Makes
into
it much
software.
faster than my counting, but
I won't go deep on software because my colleague, Corey Peoples, the person who is now responsible for software, including Workbench, did a really good show with you guys. I think it was like 2 weeks ago or so. So if you're interested in doing the deep dive, go to YouTube, look at all the useful resources and tools Shure has put there, but also check out the Practical Show Tech archive because
it was recorded and it's in the archive.
Yeah, exactly. Check it out. It's in there. Yep. So here are the highlights in the brief version that I'll give you today in case you didn't see it. Number one, first and foremost, it's free. It's a robust coordination tool that anybody can download. We just ask for your email address. That's all you pay us, is you give us an email address, and you can even check out or deselect the marketing box. So that's all we ask, and then you have complete monitoring and coordination of any Shure device that has a network jack on it, by and large. And lots of extra features. There's a DTV zip code database in there. So if you're in the United States, you could put your zip code in and it'll tell you, according to the database, which channels are up in that area. And that's a helpful tool. Of course, lots of people do scans as well. I like to do both. I like to use the zip code database and then do a scan over it. And then you can see how right or not right the zip code database is, especially in the 600 megahertz auction time period. By now, they've all been updated, but that's just a good double check. Of course, you have remote control of ADX transmitters through Workbench. So if you want to change the gain on a transmitter, if you want to change the name on it, if you want to change its frequency, if you want to know what its battery life is, that's all available in Wireless Workbench. And then we have a feature we released not too long ago called Timeline. And Timeline allows you to do a walk test by yourself and then determine the status of the microphone. So I'll give you an example. We show up to a new venue. I just set up a distributed antenna system, and I want to know if this microphone is good in the entire venue. I turn on the transmitter, I turn on the Timeline, and I could walk around the entire venue, and I can use buttons on the various transmitters to make markers. That's what those little thin white lines are. And then I can remember, okay, my first marker is at front of house, my second marker is in the hallway, my third marker is in the green room, my fourth marker is at, Guitar Land or Studio B or wherever. And then you go back at the end of your walk and you can look at this timeline and you can see what exactly happened. You can see the varying changes to the channel quality level, the antenna status, the audio level, the battery life, the show link status. So you can see how good your show link performance is as well. All available and can be saved as well. So not only can you save these timelines, but you can import them back in later if you want. So really,
is that
key
audio
feature.
always recorded with every timeline, or do you have to insert it into the?
Well, it's not recording the audio, it's recording the, I'm glad you asked that question because I didn't want to mislead anyone. It actually captures the waveform, not the actual audio. So it's not recording like a wave file or whatever. It's just.
I thought he told us there was a way to take the audio from your receiver and put it back into your computer and record it along with the waveform.
Well, yeah, I mean, you could synchronize your timeline to work with Dante, but that would be
there was a way to plug your audio into the wireless workbench and have the audio actually recorded as you walk the unit, and it would be recorded in sync with your walk.
I'm not aware of that.
Oh, okay.
Yeah.
I mean, you could use like Audacity or some other
That's what I was, yeah.
audio recorder.
What is this line right here that has all the audio recorded on it?
That's just the waveform, right? So you can play back the waveform, and you could say, oh, it peaked here. Like here's an example, Peter. So let's use my world, like the pro touring world, and an artist comes off stage after a solo, and they're like, well, dude, you really hosed me there. You know, I had dropouts the entire time. And then you're like, okay, you can look at this timeline and you can go, channel quality is good, RF is good. Oh, audio, it's intermittent here. It's like maybe there's a short in your guitar cable. You know, you could basically verify that there was signal present or not audio signal present during a timeline event, but you can't actually hear the audio, if that makes sense.
Got it.
And then logging. So we have that log, that event log I mentioned. We log everything, and you can choose what to log and what not to log, but we have the option of logging everything, every frequency change, every gain change, and lots of our customers use that log, especially in the broadcast environment where there's lots of QC, lots of issue reporting. You know, if I don't know how many people in the audience know this, but there's a dropout on a live news program, a lot of people hear about it. It's like there's a report log generated depending on the network, but everyone hears about it. It's a big deal, even if it's just a second. And so that's where event logs become really important, because you know you'll get a report at the end of the day that says, you know, on audio channel 1 of the console, wireless microphone 4 with this gain setting and these DCAs, you know, this dropout happened at 10:02 and 40 seconds, and it ended at 10:02 and 43 seconds. Like that really happens. And you can go in your timeline in your event log and you can see what happened. And it's really good for diagnostic purposes in those high pressure environments where like every issue matters. Having the logging is a really helpful tool in order for you to be able to explain to management what happened. And that's where verbose logging comes in. One of the last things I'll talk about is channels. Currently, it's only available on iOS. So if you have an iPad or if you have an iPhone, you're in luck. You can download the Channels app for free. And if you connect a Wi-Fi access point to your network, you can monitor all of the channels that are connected to that network via the app. You can sort. So I use the example of sorting by battery life, right? You want all the low battery life transmitters to show up first. You can do that. This is great for A2s. You know, they don't necessarily have the ability to sit in front of a laptop all day, but they can download this free software and it's free. You don't have to pay for it. You don't have to ask for budget for it. Just download it. And as long as you have a Wi-Fi access point on your network, your phone can discover all these devices and monitor them. For $10 per model, you can control the device. So say, for example, you want to control Axient Digital, you would go into the Apple store and you would buy the app, you know, the paid purchase to unlock Axient Digital. If you wanted to also unlock, you know, Axient Analog, for example, that'd be another $10. So it's free software to for you to be able to monitor. But if you actually choose to control, you have to pay that extra fee there. Hang on a second, because my headphones died, so I'm switching sources here. Okay. Can someone say something so I know my headphones work?
Check 1, 2.
Okay, we're good. Thank you. I just had to switch over because they died. Okay, so some technical features I wanted to share really quick before we end today. And I thank everyone for their patience. I wanted to show you what standard mode and HD mode actually look like on a spec AND. So you can see here that you can get 17 channels in standard mode, and our spacing is 350K. And in HD mode, it's 125K. And you can kind of see the different masks and the spacing for each signal, the blue being standard mode and the yellow being HD mode.
Here we show how two get spaced apart in standard mode on a spec N here. You see there are two transmitted signals at 350K apart. That's how they look on a spectrum analyzer. But check this out in HD mode. They're basically 125 kilohertz apart. They almost look like one carrier on a spec N, but that's actually 225 kilohertz transmitted signals being put butt to butt right next to each other. And finally, here is 47 channels. So when we say you can get 47 channels in 6 megahertz, we actually tried it. We just didn't calculate it in Wireless Workbench. We tried it and evaluated it. And here's an image of a spectrum analyzer showing you 47 channels in 6 megs. You can count those Bart's heads. There's actually 47 of them. And there they all are. So that's all I had for today. I'm more than happy to stick around if there are any questions.
During the walk test, how do you insert a marker from the transmitter?
You in the transmitter menu, you would go take the transmitter, say it's a body pack, you would open the battery door, you would go into the menu called called drop marker, and then once it's in that mode, you hit the enter button and it sends a message that drops a marker.
Cool.
Awesome. Got any other questions or anything else for me?
Somebody said do a video with your phone while you walk. If
you can do that.
Match up the timeline. Yeah. Matt is expanding on what he said about wondering about how things sync up, and he said back in the olden days with standard, the original remote controllable system, not Axient, analog, he had an issue where the handheld mic was not in range of the show link anymore, but the ATX 600 let him go ahead and send the command. Or maybe he wasn't paying attention to the fact that show link was saying out of range.
Yeah, well, it shouldn't actually send the frequency if you're out of show link range, because it wouldn't. Yeah, I guess I don't understand how that would work, because if it were out of range, then it wouldn't have the conduit that it needs to send that changeover.
And is the ATX 600 measuring the noise level on a channel, or how is it calculating what's a good channel versus a bad channel?
It's measuring RSSI.
Yeah.
But you're using the threshold, right? That's you know,
if it's more than minus 85, it's considered a good channel. If it's more than minus 5, it's considered a bad channel.
Can that sensitivity be adjusted at all?
Yes. Yeah, it can. That's just a default.
Ranjan wonders why WWB doesn't support WIN radio anymore.
I don't know the history on why it doesn't. I just know that it hasn't ever since we moved to Workbench 6. Workbench 5 had support for WIN radio, and that was, gosh, 10 plus years ago.
And Jason sent me the link for the YouTube.
Oh, awesome. Cool. Thanks, Jason.
Yep.
And Mark, you were just speaking a moment ago, and we did not hear you.
Yeah, I'm sorry, I was muted. But the Axient analog receivers are listening to not just the audio that you can hear, but the ultrasonic audio as well. And they can tell interference before you can, because they can hear things that you can't. And so it knows when a frequency is next to you and it's starting to encroach on your spectrum. There are audible artifacts there's artifacts in the audio that you can't hear that it hears, and it goes, yeah, you're getting interference. It's time to move. So, and in a digital system, you can start, like, you look at your link quality. Well, the computer has not just, or the receiver doesn't just have 5 bars. It's got way more than that in terms of link quality, and it can say, yeah, you're your link quality is fading. It's time to move.
It's almost the entire reason I change apartments is my link quality goes down and I have to move.
It's why Kelly's looking to move as well.
That's
Exactly.
right.
Exactly.
That's right.
Cool.
I need to go to a different Manhattan.
Well, this has
Oh,
been
that's
an
right,
absolutely terrific presentation. Thank you very much, Michael and Mark.
Gosh,
Yeah, we've got
my
a few
pleasure.
other questions that we'll that we'll pass on to you, Michael.
Sure,
And
absolutely.
can get into there. I saw a couple that actually came in on email to me as well. So we'll get that compiled, and thanks for taking the time. I hope everybody enjoyed a little more deeper dive than we normally get to on some products, and obviously this is one that touches a lot of our business and industry. So I learned
A lot of
quite a
very
bit
good
more.
questions. A lot of
Yeah, a
good.
lot of great questions.
Absolutely.
I wrote down a few things for myself on how I want to change a little of my workflow as well. So folks, you see the email up there. I know Michael is never shy about conversing. So if you throw it at him, he will correspond with you. I promise you. So everybody, thanks for
I
today. This
wanted to
extra
add
time.
one little note.
Of
For
course.
the 90 people that are still listening to us, I want every one of you to go to the question system and put in an idea for a show for practical theater tech, practical show tech. Forget about theater tech, practical show tech.
That's a different one. That's a
We
different
We'll
one.
need
never forget about theater tech, Pete.
put the ideas in the question and please, the
Yeah,
more the merrier.
absolutely. I will tease a few things that are coming up ahead. First of all, let's just make sure everybody's clear. Next Wednesday, the 20th, lunch with Pete and getting your Part 74 license. You will not get your Part 74 license at the end of lunch. Okay, so that's the first thing. Number two, the luncheon, you will not be connected up to the FCC website and walk you through applying for your license. What the whole idea of the lunch with Pete is to understand, number one, what will you and won't you be able to do? That's why we've got Henry Cohen from CP and we have Gary Trenda from PWS, both companies that will help you get your license applied with the FCC. That's how I got mine.
Me too.
I went through them. Yes, I did have to pay for that. That was not a freebie, and I was quite fine with that. What our intention is for everybody to understand what your expectations should be and your responsibilities. KP did a really great job in the RF Faraday cage match day, which feels like an eternity ago. About why should we have a license? Why is it important to participate in that process? It's not just to protect our clients who we're using our frequencies for, but also it gives us a voice in the government marketplace so they understand who are the people that are using this. So I can't stress enough, be a part of that Part 74 luncheon, but please come with the proper expectations. We don't want anybody to think that they're going to walk away with a certificate that we're going to email them that they have their
But
Part
they
74
are going to
license.
walk away with 2 contacts and you get them the license for them.
Exactly, but
The
most
important thing is where do you use this license? When do you use it? How do you actually arrange? Just because you
how
have the
do I
license
use it, right?
doesn't
I
mean
go and
you
get
can
it.
actually
How do I
use it.
use this now? It's not just about picking frequencies. And I know a lot of people love having that piece of paper and going around, hey, I don't know. I suppose if you don't have one of these, you should probably turn your mic off. It's not quite like that,
Exactly. But
It's
the cool thing is you get to say, talk to me. I'm WRAP 636.
if you ever wanted a call sign, this is how you get a call sign. Okay. Other than Rubber Duck or White Knight or listening to, some of the trucker songs. All right. So I got that out of the way. Next week, Monday, Smart Tips with Jim Yakubuski and Michael Lawrence, right? We're doing crossover. This is a Pro Sound Web panel coming over to us. If you guys are familiar with the Signal to Noise podcast, these are, folks from there. Michael Lawrence is one of the hosts on there. Jim Yak is just a brilliant guy, great human being, and very passionate about technology. This is going to be a great one. And then we're doing a little different one on Friday around LED walls. We've asked Beth Forbes to come in. She's a video engineer, tech manager, production TD for the corporate space now, and we are going to pummel her with all kinds of questions about why are the LED walls so noisy, and then she's going to tell us the new ones aren't, and then we're gonna really understand why is that technology so important, because it is, and it's a great opportunity for us to work around it, develop new products thanks to Shure that allow us to work around and meet these needs. So send in your ideas. Stay in touch. Oh, wow, look at this. They're all starting to come in here. And for those of you out there, please know we're working really hard. We're trying to come up with a topic each week. Live event, broadcast, maybe broader topic, maybe it's audio. So that's how we're looking to fill these 3-day weeks. So when you're coming up with your ideas, try to think laterally. Try to think about adjacent industries that may make your job better, worse when you're working with them. So I'm seeing a lot of great ideas pouring in. So this is
we need lots of ideas that will relieve us of webinar lethargy.
Oh, I don't see that being a problem, but you know, for Jeffrey, I see you brought in Studio Technologies. Interesting. We've been on the phone with them. We will be doing some stuff on Studio Technologies with Dante. MJ, thanks for listening to all my pushes for all the other shows. Thanks for being on, for pulling this together. Really. Oh, I think you may be muted.
I'm muted now.
There we go.
You're good.
Okay. Yeah, I don't know how that happened. Probably because the mute button was on. But yeah, I just want to thank you guys and Kelly and Peter and everyone, Mac, for all you guys are doing right now in our industry. You know, we could just be lamenting about there being no shows, but you guys are actually providing a huge service to everyone. And you know, I know that I speak for everyone at Shure that we're happy to be a part of it, but I'm really looking forward to seeing all you guys and gals in person again, and working with you guys out at shows. So thank you so much for everything you guys do, and we'll get back to normal at some point, I hope, and we'll you know, we'll be there ready to support you guys again, just like we are now. So thanks so much.
Absolutely.
And have a great weekend.
We will do shows again. I guarantee you.
And thank you for your support in doing all, you know, Shure has stepped up multiple times here at Practical Show Tech. So we're very
happy to do it
again. I'm sure at some point, you know, we're going to keep piling these. We got so many ideas now. It looks like we're going to have to stay on the air for at least 2 more weeks. So
all right, let's do it.
Sounds good, man. Thank you, guys.
Thank you.
Don't stop the webcast.